This one, right? This is the second one now. And but we have to do this one now. Okay, quick one. The same way we did the other one, safety factor of what? Safety factor of what did you use? And then you got what? Okay, that becomes our design load. So what's the next step after that? Be telling me now, you say you have done it. You select which equation to use, and then you pick which one. Q and Q. So, yesterday we already got here our alpha to be, why is this thing? Off that light in that side. Is it not too bright? Better. So we have our phi, which is 34. That give our NQ to be, what did you get? 13, right? Abby? What's our NQ? So the next step is to do what? You need to determine just determine the area. And to do the area, what do? You equate of what? So how did you get your Q of the NQ? The Q. So where did you get? What? All of you get the same thing? 419. Again, you remember how we did it? We have, first you show us a depth. You guess a depth as a trier. What depth did you? So I don't expect all of you to do the same. I will just copy what I did yesterday. But that's what I did yesterday now. It's a combined work. So if you use 10, then the depth below water is 7 meters, right? So you add 3 by 20, Abby, 60, and then the below water is what? You have 10 by 7. Ten by 7. That's 70. So you had that one to 30. Huh? So you got 130. Oh. I'm not happy. You do a parapo. Okay, you got that, and then that becomes our Q. So Q dot NQ is what? And what did you get as your NQ now? 13 now. Is it 29? Okay, 29 by 130. So what do you have? Just the same figure. I'm suspecting everybody. You don't expect the same pi. I thought somebody else should have done different depths. That makes it a little bit robust discussion. Instead of using them, it's like everybody just doing copy and paste. You did paste and copy. You all agree that you understand it. That's what I want to know. Do you actually understand what we did? If the water depth has been something else, could you have done? If the groundwater table has been 3 meters, is what we have. If it is 5, what could you have done? So let me ask you, if it is 5, what is the total overburden pressure? The water table, groundwater table, is 5 meters.
And the overall extent is still 10 meters.
Everything remains as it is.
Okay. And it's 5. So we'll calculate for the Q unit weight and the depth for dry, which is 5, and we'll later calculate for
Meaning equal to what? Go ahead.
Okay.
Do the calculation. The first part is what?
5.
Which equals to 20 times what?
He said 5.
20 times 5, that's 100. And then, is water I buried? Becomes what?
10 times 5.
Making 50. Okay, let's move forward. I think, okay, that's fine. What is important is that when you have water present in the foundation, the soil seems to be a floating soil. So you always take away that element, the weight of water, from the weight or the unit weight of the soil. It is very, very important. Okay? Don't be surprised. Sometimes even your depth may not get to water level. So I thought somebody would have been smarter and could let me try depth that is above the water level. So what did you get? But what, are you not doing the same thing with them? But what? Okay, let's try and see what he's talking about. You know, that water presence can be a trick sometimes. This is what we are talking about. 3 meters. You say you are choosing 10 meters. So now I decided to say, let me say 2 meter depth. So if I put the pi at 2 meter, at this depth, it then means my Q equals to omega d, which equals 20.2. You understand what I'm saying? So that's the first thing you should do. Because if you can avoid water, why do you want to go and be doing all this giddy way that they do? Okay. If something can stay at a shallower depth, why are you going deeper? But with your 10 meter, what did you get? What size of helical pi did you get? Only one element at 40 cm. Jesus of Lagos. Okay, so this will have been 40 and the rest is piece of cake. So if we use this one, what will have been our area? This will have been 40. So Q, NQ will have been 40.23, Abby. What's your Q? 29. For calculations, let's call it 30. Now it becomes 1,200. Abby? Just for calculation's sake, call this one 30. With this equals to your NQ. So at the end of the day, your design load equals to 1200 area. Abby? Are we lost? But do you understand what I'm trying to do here? It's supposed to be ANQ now. This is the A now. So by proportion, our A, if we call this one to our design load, what do you call the design load? So what do you now have? Now before 90,000, Abi? Over 120. What do you have? 0.4 meters square. But the control here is 5D. Is 5D deeper than this or shallower? So what is 5D? Control is 5D, which becomes 2 meters at the extreme, so it's okay. But now I've gotten D. Oh, okay. So D will be 250. Diameter. Okay, you now divide. What's the biggest number you have there? 0.1. So you need 2 of it or 3 of it. Okay. That's fine. So meanwhile, in your one piece at where? One piece at where? At 10 meters. Okay. So that settles that. So now let's see whether the torque, let's check. I've lost you, I'm sure. This one.
Which depth are you considering here?
This one.
Here, for this particular.
I just use this one like an exercise for you. Okay. I just use 2 meters. Guess. It's a guess.
The calculation of the overburden pressure, I observe it did not consider the water table. Or is it that?
Yeah, because I'm putting it above the water table.
Okay.
The first thing you check, if you can run away from water, run away from it. But now, you are in Niger Delta, you know you can run away from water. Even if it is 3 meters today, nobody knows what it will be tomorrow, especially if it is dry season. So you all have to consider all of that. But it is easier for you to first check when there is no water, so that you save yourself that headache of water. Because nobody can actually predict exact. So if it is me now, anything I do in Niger Delta here, I put my water level to be 0. So that when we have flood or anything, any design I do in the Niger Delta, I put it to be 0. So that will be the worst condition. So if you can stay when it is 0, then you can stay at any depth. Again, that is all how much experience, history, and the rest. Anything in Niger Delta, I put it at 0. So, even in our side, you can see the height. The height in the Nlng OSB is not the actual height of the place. That's the height that they claim. That is after reclaiming the land with some filling. So if you go to the water side, you see the water is always almost at the top of the slab. It's almost 0. So it's always safer. I mean, if you are sure, but you can't be too sure. So always, when you have a situation, even when we are doing your soil test, water level is 1 meter, 1.2. So to help your design, you just assume it is 0. So everything just become 20 does not exist anymore. So you just go straight to 10 times. Remove the weight of water from your unit weight, and then you carry on. Do you understand what I'm trying to say at all? So at the end of the day, let's check the torque. You check the torque requirement. So if you say you have that, you selected what size of shafts? You have gotten the plate to be 40 cm. So the next step, you have to complete it now. I mean, you didn't even bother to complete it. And what is the torque requirement? QT. 450 equals to QT, right? And you have Q to be 33. 33. So what is T? How did you get that? Is that correct? 190 what? Talk. Unit is not correct. It can't be kilonewton. But I'm telling you what is the value of the torque. 14850 Newton meter. And that works with what size of shaft? That's going to be an expensive design. So, we have done all the check. It passes the strength. It passes geotechnical capacity. It passes structural capacity. And then the embedment, minimum embedment, has also passed because we're already in 10 meters. So we can see your design has been checked and everything is okay. So well done, everybody. I don't know whether you copy yourself. Is there? SS200. Go to that table. How you people know they read it? Now just they copy the one when I like. On that table. You want me to? Is it going to show online, Abby? If I open that table, in case we have people online, so there's no need. SS200 is there on that table. If you are smart, the first number, no, that's 2. That's how they get it. 2 inches. 200 by 2. That's why they call it 200. That's how they manage to get it. SS175. What they pick is what? The diameter, because it's 1.1 Check to the table above that. SS175. What is in the bracket? 1/3. The 1 is the 1. The 75 is a 3/4. You get 3/4 is 75.75. Do you understand what they have done now? So they are telling you that the SS dimension is 1.75 inches. While the other one is 2.00 inches. 2.0. 225 years. Is that correct on the table? 225. It's as it says, that's the trick. You are lost, bros. Are you? But do you understand this one we're talking about? Okay. 2.0 inches. Yes, you said it's 200. Well, now somebody now asks a question that he doesn't know what's the dimension of SS200. And I give you a clue how they name them.
For the configuration of the SS200, I can see 4 helix on it. Can it change at any point?
You can change anything.
Okay.
Like I said, these are us. Maybe they use it often. It's not what you have required is not in the table you request. They will give it to you.
Okay.
If you want that is ready made, then you can play with it. Adjust, like we said, adjust the area. You can pick the smaller one and the rest of them. You can play with the configuration. Like the area we got exactly is 0. What did you say you get?
0.128.
0.128. We can decide to pick. Go back to the table in page 1. Because even picking it, we can say, okay, let us have 2 inches. 12 inches. 0771. 0716. Are you with me? So I want to use the bigger one to be 0.07. Okay. I had 10 inches to it. Add the two together, what do you have? Do you understand what I'm trying to say? We have gotten our area to be 0.1286. That's what we needed. So we can now say let's use a combination of 10 inches and 12 inches diameter blade. So we have two blades. That is easier to install. You had them together. So you can decide to use, 14 and 12. Or 12 and 10 and 8. It must be bigger than the area that you calculated. So whatever combination. Are you here? Bros, you getting me? Where's your partner? Are you here? Do you understand what I'm saying? So somebody can say, okay, I just want one helix. That's okay. Somebody pick two combination. Maybe he's looking at how to easily install it. Do you understand that? It is not compulsory. Since you get the answer, just pick one. Except it is, especially like we said, now you look at the table, you don't know how to select. If you want to order the part now, it becomes a problem. You now begin to write the manufacturer, make one, especially single 16 inches for me. So instead of doing that, we just, let me have a combination of what is common. 10 plus 12, 8 plus, say 8 plus, what did you get? 8 plus 10. 10 plus 14. Now not too much. Okay, I mean, that's good. I mean, that shows some level of understanding. If I decide to believe you guys, which I'm not sure, I'm tempted to do at this point. But it's okay. I mean, let's see. What you've done now, we'll see whether it's parapo or copy and paste. Okay, for the third one, which is the last one, before we have done it, haven't we? You have shown the talk. It is the talk you have used to select. So you have passed structural test. Oh, no. That is for verification of the capacity. If you want to test it, that one, there's no calculation for that one. That one is done. I was just explaining to you. For you, somebody to not accept your work, you must have tested it. Whatever you now get from your loading test, you now subject to that elastic. Yeah. But for now, you are done with design. What else? Somebody want to say something?
You said we should attend this one yesterday.
The third one? You didn't do the third one at all? All right, let's do it together. It's okay. Like we said, one important capability of helical pi is because the tension calculation, compression calculation is the same thing. Is that not what we said? The tension calculation and construction is the same thing in terms of formula. But I told you overburden pressure, if it is sand, is critical. Is it not? Because it's NQ. So again, the difference here, if you know what an helical tieback is, they already told you, helical tieback is only or specifically meant for retaining wall. Okay? So you have your wall in soil, in water. The soil is there. This is water. And it is usually at an angle. We usually install it at an angle. You can do horizontal, if it is, but I mean, it makes more engineering sense to install it at an angle. So they said they have done it at 20 degrees. I know this is where you get lost. Every other thing. You didn't get lost too? Who got lost here on how to proceed? Or somebody is already getting lost right now? You're already getting lost? Yes. So they already told us first. Let's take step by stage first. We have a design load of what? 70 kilonewtons. Sorry. Yes. a design load of 70 kilonewton, we're supposed to have factored it if it is our work, but let's factor it by 2. And what do we now be? It becomes your Q ultimate, QU equals to 140 kilonewton. All right. There are 2 ways to it. This is our line of work. Okay. So, but the distance is like this. They say it's horizontal, this horizontal. Is that not what the question says? Abby? We are good? There are 2 ways to it. First, you can decide to find the component of 70 that is moving along this direction. Simple physics. Mechanics. So if you have 70 like this at 20 degree resolution of force, what is the vertical component? Your calculation is used to vertical. Is it not? At the end of the day, this force going this way, because this is at 90 degree, is going to have both vertical component and what? Horizontal or diagonal component. Because the horizontal component is what we have here. Hello? Triangle of force now. You have forgotten. Patapata. Mechanics. Sukatu has come. So that's the easiest way, because what you have been doing has been vertical compression. All this formula you have been using for soil has been vertical. So you always, what you do is try and make this component vertical. It will now appear that you are resisting vertical load. Hello? Do you understand? Jesus, this one doesn't understand. We have a load acting this way. Our soil is not acting like this now. No. 20 degree question. Sorry, 70 degree. It said horizontal design load. Horizontal is horizontal. It's horizontal. Along x-axis. It's 70. 70 kilonewton. But what is resisting it is at this angle, which is 20 degree. If that is the case, for the resultant to be along this line, for the resultant to be here, you need to have horizontal components and vertical components. I'm sure you are lost in physics. That's your problem. When you say you are pushing an object along an inclined plane, when you are doing machine or whatever it is, work done. You still remember? Have you ever remember you saw this thing in school? It's coming back. I pray it comes. So this is 70. They told us this one is 20 degree. Abi? So what is the vertical force? Sokatua. It's Sokatua now, is it not? It's your business if you want. You already have an angle. You have one side there. So form a triangle of force. This one becomes the 70. So if you want to put 70 here, that's your problem too. This is what it's saying. If the force is like this, and then we have this, and the resultant is this way, and instead of putting 20 here, I put 70 here. Is that not what you are saying? So this one comes back here. And then this one becomes the opposite of this one. Abi? This becomes the hypotenuse. What we want to calculate is the opposite. So in Sokatua, if you remember. So which one do you use? Anyone? If you want to use this one, you say sine. You don't come up for head though. Sine L0 over H, which you don't no, you have to use this one because we know this one. You have to be, everything has to do with your, if you are adjacent, it has to be cos. Or tan. Opposite of adjacent, that's tan, Abi. It's coming. Opposite equals to x over 70. And s equals to 70 tan theta, whatever it is, tan 70. Abi? What do you get? Oh yeah. Tan 70. One point what? Tan 70. Times 70. Yes. Yes, sir. Opposite.
Is that 0?
Oh, I got put it opposite. This is theta. Why are you confused now?
No, if it's theta, then there's no value for either one.
Theta is 70 now.
Now we still have s over 70 again.
It's because the horizontal component is 70 kilonewton. So what do you have? So that will be the force that now be acting like your compression or uplift in the soil. But it's pulling out, so it's acting upward. So if you are drawing your soil again, you put you now assume your helical pi is vertical because you have done the vertical component of it. Do you understand what I'm saying? So that means that your helical pi, but it's only one soil, Abi. You now appear that your helical pi is here. And the force pulling it out is what? 190 kilonewton. The rest is what we have done. You go back to, okay, this is 192. This you already factor, you now want to factor it. You happy? So the first step is multiply this 1 by 2 to get your design load or ultimate load. That becomes 384 kilonewton. It is actually inclined. But for calculation's sake, anytime you have an inclined force in physics or in engineering, like I said, it's two ways. For now, all we have practiced are vertical forces. Is it not? You have to translate that force to a vertical force. Do you now understand it now? So if I push this here, horizontal with that force, and there is an object that is inclined, it's going to be taking higher force. And that's why when we are making this, I want to say if wind is blowing a house, it's a very critical issue. If it's a tower that if it's a tower that have a, you know what a tower is like this, and then you have a wind blowing here on a tower, the force acting in that direction, you have to calculate it based on the slope of this tower. So for you to aid calculation, to make your calculation, and like I said, two way, since we have been doing vertical, I try to use all vertical all the way. So I started with my force and get the vertical component of that force. So you can apply, we'll do the other way too. Do you know what I'm trying to say? Is anybody still confused? Is anybody still confused? Or do we all understand? You don't. There is no way you can calculate anything on its own, at an angle without resolving it to vertical or horizontal component. Okay? So, that makes it easy for you to calculate if it is straight horizontal or straight vertical. And this is what they use in design. But we know that the easiest way or the most common forces when it comes to foundation is always vertical. So if you have an inclined load, you try and make it vertical. So it's easy for you to now use your normal vertical analysis of soil. You cannot carry your hand to make it vertical because what you are consulting cannot be vertical. But you are sure. The problem is that you are doubting resolution of forces. You are doubting it. If you are not doubting it, it will not be difficult for you to understand that anything happening at an angle has both components. So you are now pick one of the components to represent it, and your life is easy. This shear is having a width, and I put this angle. My hand is an angle, is it not? And I try to push it. Is it not going horizontal? Part of my force that is at an angle has a horizontal component and also has vertical component. So the vertical component in this case is less. The horizontal component is higher. That's why it's moving. If I'm at an angle close to vertical and then it stops moving, the vertical component of my force has increased. So it is the angle that is determining that. Do you understand what I'm trying to say now? And the question did not tell you that the force is along the helical anchor. He didn't say that. He said the force is horizontal. Actually, if you are doing full design of a retaining wall, your active force or passive force retaining I don't know if you have done it before. If you are doing retaining wall, this is the wall, this is the ground, this is the water, and you put a force here. A surcharge. It's a vertical force you have applied, but it has horizontal component with your active force Ka, K. I don't know if you remember those small retaining wall. This is not a class for that. At the end of the day, by the time we calculate everything is always horizontal component because this wall will be moving like this. At the end of the day, the failure of your retaining wall is to move horizontally. And then we have to, your anchor you are putting must provide opposite force. That's why I said that this anchor sometimes can be straight horizontal. It is when it is difficult to get horizontal. Immediately you bend, you have an advantage of reducing or increasing the resultant. It's not entirely vertical, but you try and make it vertical. Then we ran into a problem. It became bigger. We started with 70 and it became 190. So now we are looking at the vertical. Is anybody still lost on that one? Or are you still in the middle? Don't just, no form, okay. Bros, you understand that? So now we are looking at 384 kilonewton as our design load now. Then you go to normal, and the soil is what type? So which equation are you going to select? Q and Q. There is no water here, so it makes our life easy, Abby. There is no water, so they already give you the NQ to be 21, so you are not looking at any table. They already give you NQ to be 21. Sometimes soil test or soil report will give you everything. So that means the man has done this job, has gone a little bit further. So, then the next thing is you assume a depth. Assume a depth of your anchor now. You assume a depth. You say 6 meters. So when you do 6 meters, what is the overburden pressure? So if you say your depth, but don't forget, everything is vertical. This is very tricky. This is the helix now. You have put it here, and you say it's 6 meters. The 6 meters is from here to here or from here to here? It's vertical, perfect. So the 6 meters is here. Already you call it overburden anyway. On top. So you have your omega times that acting on this blade. Do you understand? With shows, trial. We got 6. When you are doing your own, you can do anything you like. You can put 10 meters. So if your depth is here, the overburden pressure here is the unit weight of soil times the depth you have chosen. You are still lost. Or you are getting angry. So, and the soil weight is what? 17. Right? So it becomes 17.6. What is that? Abi? 1 or 2 kilonewton meter square. Anybody lost at this point? But you did. That means you copied the one of yesterday. But nobody is talking. If you don't talk, you're making me scared. Do you understand it now? So, we already have our omega D to be 102. Then the QNQ, this is our Q now. Abi? The NQ, we know as what? 21. So key NQ equals to 102.21. What do you have? 214 kilonewton. Okay, it's 1,000. 2142. Who doesn't understand this? Take your time, do your calculation. I don't have a good handwriting on the board. It's very ugly. Consign yourself. Huh? And doctors. I have a very good handwriting on paper, but on the board, no. Actually, I hate writing. Nice for you, and so you are specialist in copying. Have you all done the individual calculation? Are we getting the same number? You have jumped to the next step. Is that what everybody is doing? This man is jumping the gun. Is 2142 everybody accepts is correct? Okay. This is supposed to be with area and Abi. You now put it in A. Our Q, U equals to 2142A. So our A equals to what is the design? 384. Abi? So 384 over 2142. Madam, Do you know where we are? Huh? I'm not going to write again. And I'm going to do the rest. So what do we have? So what's the next thing? Coco. Senior Coco, what's the next thing? What's the next thing? Next Coco. You have calculated the area. What do you do as a designer? Go to the table. Page 1. Coco, you are lost because you came late. How can we help? You can draw us back. We are not complaining. But it's better here, we can share it together. Where are you lost actually? Everywhere. It's also Lagos. But you didn't do the one I gave you yesterday. That's why. You have taken us back 2 days. I know. So in that area, what do you have? What combination do you have? Do you have anything close to it? We have 0 point. What do you call the answer? 125. 180 now. Let's not fight now. So that we can be happy. So which table? Which size? Coco. Check for that table, 0.18. What am I 615? Which table are you looking at? Let me see the table. Show me. Show just display it like this. Yeah, that tiny table. This is metric. Oh. This is millimeter square. Or meter square. So look at which one represents, the one in bracket or the one outside the bracket? Which table, which column of the table are you looking at? The first or the second? No. What is the title of the first one? No, the first, not the title of the table. The first column of that table you are looking at. I said one of the column, the first one. What's the title? Are we looking for a diameter? This is what? So that you are looking at the round column. So look at my face. Look it there. So you check the next column. Yes, say anything more than 8 or close to it. Above it, that's what you look for. Equal to it or above it. The one outside the bracket is in imperial units. Where is he getting that? Is there anything like that there? Let's read the table one by one. I think it's lost. You are totally lost. Let me display it on the screen. Because I think everybody is also lost. Are we all lost? No worry, no quarrel. We'll get there. We'll get there. I'm not fast. I'm not as fast as you are. He's tense right now. I don't know what's the last one, yeah. The last one is not 0.1, is it? It's not inches. What's the unit of everything in bracket? You said inches, bros. Maybe I'm hungry. I'm not hearing anywhere again. Morning, boss. 0.12. That's the highest on the table. It's not that in there, but that's the highest on the table. So now we want to go to 0.18. So we want to use the biggest one on the table. Right on, boss. If you combine 16 and 12, what's the number? 0.0. Madam, what does that number mean? Call the numbers for me. Eh? 1. This is for the 16 inches. And the other one? 0.71 or 0.72. This is 12 inches, Abby. Is it 12? Yes, sir. So you have 0.19 or 120. That works. Somebody else can pick something else. Okay. 214 inches will be 0.14 inches is what? 1.005. 0.05. 049, Abi. No. 974 times 2. I'm confused right now. It's 0. Okay, not 1 point. 0.195. Abi? Okay, that's the total, Abi. We multiply by 2. It works. So that's why designers will get different things. That give you, I want to own it. You want to own it. Yeah, this is. But it's always difficult to construct. No, that one clear. When the sizes are the same, it's difficult to turn. To turn 14 inches together at the same time is very hard. You may need more torque. It may end up giving you a too big. So always look for where it is tapered. From small to next to small to next. I can also take 3. And I said I want to start from 8 inches. So it will be like a pencil. The more pointed it is, the easier. That's what it must be. So small, yeah, because the small one, I ain't go touch ground first. It cut and small. No, all this combination we're talking about, the lowest one is the smaller in size. It's the first one in contact with the soil. You don't want to have difficulty doing that, so you don't break anything. First one go easily, the next one struggle small. And so they go the soil. The first one has disturbed the soil a little bit. You don't soft ground. Like that. So we always, instead of having 2 sizes the same, we always try to look for the more pointed your helix, the easier it is to install. And it doesn't disturb anything. Your resistances will also be perfect. So we have selected this one, for example, or this one. So that gives us, go back to QT, right? Our QT, to get the torsional resistance, is QU over 33. Abi? I don't cut corner. Torsional resistance is ultimate capacity over 33. I like to cut corner. Do you know how I arrived there? Because 33 is the KT value for a square shaft. So now this area, and this, what do you call it? Which one are we going to use? I wanted to have whether it's this one or that one. So you use this one. So that is 2142 divided by 33. What do you have? 64.9 times 1,000 now. 65,000. Is that correct? I'm going to check now. Our key what? You are correct. Why are we going that far? We don't have to. This is our design load. This is soil resistance. Even though this is what appeared that we have installed to in the long run, Abby, but immediately we get these results, we can stop now. Do you understand that now? If you are now turning it and you are measuring your torque, you keep on measuring your torque. If you get the torque value that is this place, you can stop. But in the recent, they will ask to say, okay, this is what we have designed for. Get there. We are lost again. Because you are not dealing with a vertical load. This is the vertical component. You understand? And you are correct. This is what we use. It's not the what we get. Okay, it's 12142. You are correct. Sorry. So the answer is this one. 384. You are correct. It's 384. Correct. Sorry. So what do you have? That's almost 12 now. 13. 12. Huh? 12,000. 12,000. Without touching calculator. I go tell you, I don't do calculation. I go the right jump for people. I just say pia. 12,000 Newton meter. So go back to the table again and select a shaft. Select a shaft. SS175. That's 14,200. You all agree? Are you enjoying this class? Now so now we didn't bring us to this side without it. Now we just design to. Everything you have done here is exactly what is on site. On this example. The next thing is that okay. Because you are looking at the wrong table. Table 2. That's where we pick torque. It's torque we are checking. That's the page. After determining your area, selecting the blade, the diameter of your blade, or the steel plate, or the helix, the next thing is the shaft inside the helix now. Yes. Yes. If you are not patient, you can go and select SS200 because you see 16,000. Abi? Well, 16,000 is in metric. Is in what? Is in imperial units. Have I told you why most of this are imperial units? Because it's the Americans who have taken over the use of helical. That's why you see pounds, kilo, pounds, all of that imperial units. That is verification. We have not gotten there. That is, you have after It now depends on two. There are two ways. Like what he's saying, everybody listen. It's asking at what point do you want to verify what we have designed? Is that not what you are saying? That's not part of design. That's a post-design work. You can make it post-design. You can also make it post-installation. For you to verify, you can verify post-design and post-installation. Do you understand what I mean by that? After design or after installation. How do you do after design? After we have done with this one, we look at our engineer, supervising engineer, they check, they correct, they accept. Okay, this design is good. It's okay. Before we start, let's do a trial. We go to site, we install one pi with all this information, then we verify it. Two way. We first verify that we attain that torque. It's either we attain that torque or we attain the design depth. You understand? If you give us good results, we say go and do it. If the result no reach what we expect, what do? You redesign. You can redesign, but that is wasteful. You increase the number of pi. So if in the whole project you have 10 pi at 33 meter spacing, you can now say, you know what? Let's make it 2.5 meter. Since you already know if you are doing 10 at 3 meter and one is 70 kilonewton, I'm 384. That's 384 times 10. The total resistance you are building. It becomes 3,840. We'll now do a test and the result is now giving us 200 instead of 384. So how many 200 will give us 3,840? About 15. No, it's more than. Is it? No? 17? 19. So instead of using 10 anchor, we use 19 anchor. Does it make sense? You want to go back to go and design, you still get the same thing. Because everything you design, result is what matters. If you not go and redesign, you have to do another test. That you should now choose another blade. Instead of 12-10 that you have picked, 12 and 14 you have picked. Maybe you now say everything 14. You say go back one and do the 14. But the test that you have the record, in order to avoid going back again and do another test, you could increase the number. You still get your 200. That's what matters. As long as the separation between them is what? As long as the separation between the pies are what? 3D. Do you understand all of these things? But we have not gotten here. We have not finished this design, no. Because we don't know the length of the helical. Do you know the length?
The torque resistance we are looking for, that's the QUA. You know, at this point, later, the value we calculated, that's what I want to ask now. From, yes.
What's the value of torque we got that we are looking for on that table?
Okay, I want to confirm, I want to ask Awig, yes, because I'm a bit lost from there.
You are lost actually, yeah, that's the right word.
Okay, so
Mine was not here.
the QUA divide by 33. We looked for the QU there. We got
384 by 33. It's 384K.
384K.
It's a kilonewton. The unit of torque on that table is what? Go back to the table, don't look at your calculation. What's the unit of torque there?
Is Newton meter.
So we've applied 384,000.
Okay. Because I got 2 points. That's what I'm asking.
You got 2 points?
2.09.
384 by 33.
No. From after my calculation,
There is
as
no
in using
calculation.
that.
It's simple, straightforward. It's 384 over 33. So I don't know what to divide it. So what did you divide?
The 384, we use it to get the ultimate Q first.
It's the ultimate that you are looking at.
And we got 0.18 before we started looking at what two.
It's totally lost. This
So-
is for area.
Okay.
Do you know actually how we got the area? Were you see with us?
Yes.
You don't seem to. Does it look like it was with us?
Sir, the area was given from the question 384.
Area.
Yes, sir.
In the question.
Yes, that.
This is man is in my 3.
He's already thinking about weekend.
So please let me understand from that point.
Because you were busy writing. All the time we were doing this thing, you were busy. I warned you people, do more of listening than writing. You were busy writing and you were writing. Only God knows what you are writing. You are not even writing like this madam. That madam, they see her. She just a copy. She just a writer. Anytime we show for board, you don't write them. Okay. I don't know where to start. Obviously, we have to start from 0. That's what you are telling us. Which one? Do you know how we got here?
Yes, sir. Yes, sir. That's a 2142. Yes, sir.
Not in your book. Do you actually understand how we got here?
Yes, sir.
Summarize it. How did you get there?
Okay. We used the row 6. We multiplied. The row was 17. We multiplied by 2. We got Q 102, and then we now use Q and Q. The Q was 102.
What does it mean? What does it stand for?
Okay, it stands for the overburden pressure. So the overburden pressure was 102, and then we now got the QNQ. So we multiply the 102 by 22. The NQ was given from the question, which is 21. So 102 by 21 gave us 2142. That was why we got that 2142. So we're now looking for the Q ultimate, which is 2142A. So it was.
You are lost at that point. We are looking at the area here. And that's when we now say Q ultimate over this. It's just because we jump instead. That's the problem. You are used to line by line.
That we're making A the subject of the formula.
Yes.
Uh-huh.
Then we got 0.18 meters square.
Yes, that was. I got.
And then we selected that plate. Now we are finished with that step. Helix or helical pi consists of this part 1 and this part 2. The calculation we have done has succeeded in ticking this one. So we need to tick the shaft. Meaning that all of this one has nothing to do with it again. Then we'll go back to the design load, which is 384. And then you use the formula for torque. I was asking, do you know how I got to this place? You will know. That means you didn't know. So to do that one, you now said QU ultimate equals to KT. That is the only way you select this, not through all of this. And you know QT to be 384 equals to K for SS shaft is 33.
So you make T now the subject of the formula.
So you like line by line.
Thank you, sir.
Any other one? It seems we are not hungry today. Everybody's happy today. Because the assignment helped. It boosted the ministry that we don't get them. Yesterday, Blazer was speaking Chinese. So, are you cashing up? We wait for you to cash up now?
Yeah, I'm okay.
You want to copy?
I'm okay now. You can continue.
No, right. I will not continue because you still bring us back. So better we wait. See, madam, she don't finish copy. In fact, she has copied what I want to say. Yes. Is it interesting? When you are done, let us know. Don't rush you so that I don't even copy wrong thing. Then I can watch pass. Do you have people online?
Hello, Mr. Osita. Mr. Osita, can you hear me? Online. You can unmute. Is he with us? You sent him this thing.
Yes. He didn't send us YouTube link today. Why you don't ask? I don't even check my phone. In fact, I woke up, stood up from the bed, and I was coming. I was sleeping.
Hello, sister. Can you hear me? Okay. If he's not hearing, because just to confirm, he got the manual and is following up, so that because he is the assurance person and it's good he's carried along. Yeah, GP. Michael Goose team. The other guy. He sent my. He's the one that this guy nominated.
So that bros that came first. Was it the one that said he wasn't hearing yesterday? Okay, that's true. I sent him the yesterday's manual and
Are we ready? You want to say something? Okay, the link, I'm still waiting for it. Okay. I'll send it to you now. Boss, I don't see your link. Oh. Maybe my eye is seeing something. Am I hungry? You know, I have it. I've seen it. Okay. So now, we need now to know the length of what to buy. How do we know it? We know this one to be 6. Right? We know this angle to be what? 20 degrees.
Hello, engineer sister. Can you talk now? I think you have unmuted.
Yes, confirm you can hear me.
Yes, we are hearing you.
Okay.
Okay, can you please get closer to the microphone? So,
Yeah, Osita, can you hear us?
Yes, loud and clear.
Yeah, good morning. So I'm just trying to find out if you're following up, and if you are.
Yes, sorry, I just joined, but I got the manual yesterday, so I looked at it over the night. But I just joined there, so let me follow up as the lecture is going on.
Okay, so in place of if you have any doubt, just don't hesitate. Maybe you don't even need our permission. In case you are raised your hand, just talk so that we can stop and attend to you. Or do you? Maybe we'll do a recap.
No, let him go on. I will follow on.
Okay, follow
Where
up.
I have issues, I will notify and ask questions.
All right then. If you're okay with that. All right, thanks. Then we're going on.
Thank you.
Okay. Now we have determined the depth, vertical depth, which is 6 meters. It works. And if it's not work, we'll have repeated everything we have done. But it's okay. We're happy. It works. So we know this side. We know this place. So Katwa again. I want to do. Is it not? We are looking for opposites. Abi? What do we have? We already have this force. Do we? We don't know this distance. Okay, we know this one. It's correct now. We know the opposite. We are looking for hypotenuse. So that is what? Sine. Sine x equals sine 20 equals to x over h. So h equals to x over sine 20. Okay. Is this 6? This one. It's 6 now. From here to here is 6. Okay, it's supposed to be 6. It doesn't mean now. I just put S. Doesn't matter. I got put 6 in the final calculation. You know how to use that calculator? Bros, do you have a problem with light? You are using your phone light. Do we need more light? I don't want times 20. You don't know what's times 20? You don't know how to use calculator to go all the way? Give me the answer. Go ahead and give me what H is. 17.54. Do you have any helix that is as long as 17.54 meters? Convert it to feet so that it will be easier for us. I don't know whether the other table. Show me the other tables now to select. Let's start from table. You already pick which combination are you looking at? We are saying 12 and what? I don't like this 16 now.
Okay.
12 and 16. Ah, okay, it's only 2. So we look at, and we said it's SS what? SS175. To go to the table for SS175. SS175. We don't have 16 inches combination, but you can say we can always order it. It's not really a problem. So, we have 2 blades. So go to 2 blades is A and B. A is 1 blade, B is another blade. Table 11, yes. That is thickness. Huh? Is it under it? The meaning of T after plate diameter means half. So the thickness of the plate is ½ inch. That's what they're telling you. The thickness of the plate is 12 mm. Why the other ones are whatever they are? 3/8. The other one that doesn't have a T, the thickness is 3/8. What is 3/8 in millimeter? I bet that for another day. So that's not what we are looking at. So from this table now, you look for a double combination, a double combined screw or lead. The lead is the first one. Okay? The lead is the first one. So if you now want to order, if you look at that table, column A means the last helix, the bottom, followed by B. So let me sketch it. This is A, B, C. Already we have selected a two-man pie, right? It doesn't matter what you have there. You just understand that one. Like I said, this is just a generic table. So you look for, if you want, check the lengths you want to pick. Pick anyone, whether 2 combination or 3 combination. Okay? Let's just pick anyone. Look at the table, catalog number. Use catalog number to measure a number. Certainly not the first one. Not 150010. not 1500010. Because that one has only one member. Abi? Are you looking at what I'm looking? The next one is 150012. Abi? We have 80 and 10T. Go to column 5, nominal length. Is 5 feet. Is it not? So now let us build our helical actually as designed. We have the shaft SS125 or 175. We have 12 here, right? We have 14 here. The bottom clearance is always no more than 100 mm, 4 inches. Okay? I'm using inches now because that catalog is in inches. From here to bottom is always 10 cm, which is 4 inches. This diameter we said is 12, right? Abi? 12 inches, where this one is 14 inches. So between here and here will be what? What do you call it? 3D. 3 times 12 or 3 times 14? 3 times 14 is how many inches? You are already, I don't know, you are already... Inches. I said inches. 14 inches. 42 inches. This one. 43 inches. Right? What we are trying to calculate is the length of the rest. And we know that we are going to how many inches? We are going to how many meters? We are going to 70.5 meters. Which is how many inches? 87 feet. 57 feet, correct. Feet is one stroke. Are you with me? Or you want me to write FT? Eh? You don't get this part. Good, beautiful. From our design, we have chosen to use 2 blade, 2 helix, 12 inches diameter, and 14 inches diameter. The way they produce it, from the mouth to the first one, it's always 4 inches. This is a standard size. We are not the one that did that. That's how they produce them. Now, the space between this one, we forget it's supposed to be 3D, minimum. And the diameter will be the higher, the bigger one. So 3 times 14. That gives us 42 inches. You agree? So this is 42. Okay? Any issue at that point? This is what our lead auger is the starting one, the one at the bottom. This is the minimum it must be up to that point. So if you are now going to the catalog, this must be in your hand. 42 plus 40 plus 4. So how many feet is that? Because the table is in feet. Divided by 12. Inches to feet is by 12. Almost 4 feet. That's 3 feet. I don't like something. This is a known figure. Tell me what it is, not abstract. There's nothing something. 3 feet, 10 inches. So it's assuming it's 4 feet. So minimum we have here must be 4 feet. Even if they cut it here, we'll connect it to another one. It doesn't matter. So you go to that table and go to that nominal length and look for the one that is more than 4 feet or close to 4 feet. The first one. I've told you that the first one I don't want it because they have only one blade. Am I seeing where? 57. We have 57.8. We have 57. We don't have 40 something. So we can take 0012, right? The second one. It's the same thing with the 51. Where is the 51? Give me the number. 180. I hope you know the number I'm saying. I'm reading. That's 5 feet now. So we can take that one, any of that one. They will produce it for you. It's like, it's not something you expect. I just go to Spark. It's not in ShopRite. Just go and buy it. So you now tell them, but they will ask you, how do you want it? When you want to order the part, they'll say, how do you want it? Do you understand? Are we winning?
So, sir, we are taking the second rule. That's 15001.
No, same 5 feet, if that's what you want, no problem. Okay? Somebody is looking at 180, 0180. And I will prefer that.
That one is 3.
I will have picked other small size. So you now tell them to change, they will now change. If you pick the second one, which is 012, they will change that 80 to what? If you pick the number 2, the 80, the A blade will be what diameter? Are we sleeping? 12. Now I want them to say it. We have 2 blades, 12 and 14. So which one will be the first one? This is our A. The second one? B. So we have picked that one, 5 feet out of our 57. Remaining how many? 52. Then you go to, do I have the extension there? Scroll down. Yeah? Let me do it again, sorry. Yes. I've told you it's not in the market. This is just a catalog that they just produce. It's not in the market. Anytime you want to buy, you cannot say, give me. They will have to produce it for you. You have to. What is important is just the shaft strength. You don't go. It's not clear? Bros, if it's not clear, let us know. Engineer Salami. I didn't put it there. Oh, let me show you, sorry. In that log, in the extension table, I can send this data as a very big product catalog. This is where I copied this from. SS what? 175. Abi? This is 175. This is its extension. Maybe 12. So, let me show you. Yeah. So we now begin to look at site condition, equipment that we have, their capability. Already, somebody is thinking. The designer has done his job. If you are just a designer, you're a contractor, your work don't finish. Okay? But if you happen to be that you are an internal person, you are the one also raising an MTO. You know what an MTO is? Material takeoff point. You now want to advise your company. This is what you need to buy. After my design, this is what we need to buy, at least to do the trial pie, if you don't want to buy all. So, this is the extension to it. Look at their table. Look how many feet they are. 10 feet, 3 feet, 5 feet, 7 feet. So it now depends on the machine you have on site. You now ask your equipment manager, what do you want to have? Do you have an excavator? Do you have a backhoe? Do you have a skid driver? Do you have what again? Anything you can think of. Anything at all that has a dolly system. So at least in our own case on this project, we have an excavator. An excavator can conveniently take 10 feet. It's not difficult. It's just 3 meters. Do you understand? So I'll select 3 meters. But if I don't have, maybe it's heavy. People cannot carry it. Maybe in a hand, maybe the side too. It's a remote area. That even the machine to get there is hard. In a hand will carry the material and reach the side. I look for the smallest one. You understand? I pick 5 feet. Maybe that's the second one. Okay? And then we have how many feet to complete? We need 52. So I will pick 11 of 013. Abi? That will give me 55. Are we present? If I pick a 7 feet, how many will I order? That's 014. 7, okay. I need 52 meters, 52 feet. 7 times 7 is what? You know, original. You can cut it. Yes. You can do that. You can do that. But the question gave us, no, will it reduce? Okay. But the question gave us an angle determined. Okay. In practice, if you are an engineer, they don't give you any angle. You determine that angle. You play with all the angles, and you take the most economical. But we don't usually allow it to go more than 45. And in our site here, we actually use 45. You can do whatever you want based on your capability as a contractor. Okay, I agree with you. Whether you have machine, whether in a hand you want to carry turner, you have to be something that you can carry. Your hand will finish. Even though you want to use excavator, maybe the hand of excavator cannot get to, but you can PTC together and couple for excavator to continue. So these are all the things you consider before you now select. This is not a design situation. It's a construction. You now call your construction manager, oh, yeah, I don't finish work. Let's look at it. What is available? Everybody comes together to decide. So, whatever you learn, you decide. If you want this catalog, it's online. If you want it, I'll give it to you. Whatever you want. There are practice questions online, a lot of them, if you want. So, can we have a small break? Yes, sir. Because somebody is sleeping. Yes, sir. Please, go ahead.
No, the one with the example, that one with the login, that last example, that login.
We should go to it straight away. Okay. We want to go for it, let's go for it. So the third, any question on this one? Any question at all? Is there under the table? It means that thickness is ½ inch. What they're trying to tell is that it's not something they do every time. So that one, if you buy the blade, it is good to get it at ½ inch. You come and sue us so that it will be the same size as the other one. Aha. I would like to cut case in Niger Delta here. Okay, the third practice question, we'll go back to the slide. Is it the third or the... Okay, the practice question now. We're supposed to have done this one in the house. That's what we did now. That means it's done. Is there another one? Okay, this one. But this one is vertical load now. Everything here is in feet. Who want to lead us in doing that? Who want to lead us? You want? No, I don't want him. Who want to lead us in this one? Okay, let's do it together again. I hope Engineer Osita is there now. We have design load or given load of what's the value of the load in that question? 12.28 kilopounds. Keep. If you are doing calculation, you see this. Keep. You know what it means now? Kilopounds. Okay? Our safety factor is 2 for permanent construction, because this is for a house. Therefore, our design load, I'm just using all of that, equals to 12.28.2. That gives me 24.5 or 0.6 kilopounds. Keep. Abby? Oh, don't forget it's 20,000. That's what it means. I just don't like big figure. Then what's the next thing? What soil is that? Look at the soil log. Is it clear? Okay. Your wallet is too much. You're happy now. We are not calculating like all we need to get is the principle, okay? But so maybe you're not compatible with that, just like me. It's okay, 12.228. Whatever you get, it's going to be 24 points. I'll be 23 point something. Is the calculation changing? 24.5. You all agree with that figure? In that soil log, everything here is what? Clay. Now, looking at that log, this needs a professional decision. The topsoil is there. How many feet? It's an OH. OH soil means organic soil. This is a difficult soil, I told you. This is not a soil you want to put any foundation. So even though your calculations say maybe you can stay there, you will never put any foundation in organic soil. Okay? That's why you see it in black anyway. OH. That is soil classification as a civil engineer or a geologist. Then, you can also not put a foundation in a very soft soil. So the next soil is there what? Soft clay. Are you with me? You can also not put any foundation in soil clay, especially when you have other better soil. Even though you can carry your load, you don't do that because the settlement will be high, a lot of problem can come out. Okay? So we are left with what? A sandy clay. Is it not? Is it a sand or a clay? Okay. And they say, they just say sandy, silty, clay, and it is what? Stiff. That's a good soil to keep your. If there is sand close by, we also want to dodge clay and go to sand. These are decisions you will make as an engineer looking at this report. But one thing is very clear. Soft soil, loose soil, soft in terms of clay, loose in terms of sand, you don't want to put any foundation there. Organic is a no-no. Do you know why we are not picking organic? Because? No, yeah, not really. But it's because it's organic. Organic activity is very high. So we are putting iron on the ground. We are putting in foundation there. All the things we go shop the iron. They're there. Don't say because they have guaranteed you 100 years. You now go and carry meat and say dog to keep it. Even though you have put poison in it. You alright? So they keep all of that here so that you now, as a designer, you now say, you know what? You know. If anybody come back and say, yes, I've done calculation, calculator, correct, everything. You look at the supervisor and you say, you don't know what you are doing. Okay? Difficult soil, soft soil in terms of clay, loose in terms of sand, you don't keep your property there. When you have sand close by, even though you have stiff clay, if sand is very close and it's medium dense, minimum. When I say a medium dense sand, what end value am I expecting? Yesterday result. Go back to that SPT correlation table of yesterday. But I need to know where I am. Nine minutes. So on a soil log, you see sand, and it's giving you 11 to 30 range. This is the starting point to put your foundation for sand. On the high side of it, not 11, no. You know it's 11 to 30. You begin to get 15, 16, 17. Except there's no other soil, you can use 11. But if you are getting 12, 15, 13, 14, 20, you don't need to go further. Even if you go further, it go hard for you to install it. That's why sometimes people install 10 meter pipe, 30 meter pipe. By the time they are driving it, pipe no past 10 meter. There will be a lot of wastage they will have done enough wastage to cast the concrete, only for them to not able to use it. Or you have bought, if it's a steel pipe, after buying them, you are not able to drive them down. Because the soil becomes very hard. So the general practice, you don't put soil in soft soil, soft clay. You don't put foundation in soft clay. You don't put foundation in loose sand. You don't put foundation in organic soil. You can also have organic sand. Some sand with organic content, yes. You can also have organic clay. Except when there is no other choice. They will have to find a way to treat the fuck up inside the sand. That's a situation like that. We have faced it. We just don't have any choice. That's the only soil around. There's organic in it. You see some clay inside it. You see some wood. When you do sample, there are wood inside. There are some decaying organic components inside. You don't have no choice. You keep your foundation there. But as a rule of thumb, these are areas you avoid. So if you see a soil log, the first thing you want to do is run away from those ones. And then we have the stiff clay. So already from 0, the stiff clay is, what's the thickness? 5. It means 5 meters or 5 feet. We can never pick that depth as depth of installation. When you also have a new soil, that is at a boundary of a soil. You know, now somebody, they carry high, they measure the thing. That is bound to be error. You get. So you cannot just say, since from 5 is okay, I want to put my foundation in 5 meters or 5 feet. What if the man, the 5 is reading 4? Or maybe the man shopping Kwabi overnight before a log. Now 6 he call 5. And your 5 can't fall inside the soil where you don't want. So at the same time, at the beginning in a log, you want to start your foundation at least 3 meters into the new soil that you have chosen. 3 meters is how many feet? 10 feet. Abby? In a real ground. But this result, what's the total thickness we have? How many feet you have? 20 feet. So you don't want to stay at the boundary of any soil. Because normally in soil log, the error permitted is between plus 1 meter, minus 1 meter. But you know, in Nigeria would they? Like I said, it depends on who is doing the test. That's part of the thing that will determine your safety factor. So if you know who is doing, if it's Evomec that is doing it, they have equipment, they have competent people. If it is anybody on the road who is just a geologist or you are not sure of the result. So you now say the minimum embedment I have for this soil will be 5 plus 10, which is what? 15. Do you understand what I'm trying to say? Hello? You can also use 2 meters anyway. 2 meters is allowed, which is 6 feet. I got 5 because 0 to 5 is topsoil and organic soil and soft clay. So if I had another 6 feet to that, that would be what? 11 feet. So the minimum embedment I'll be looking at will be 10 feet. Do you understand? Even though every other calculation can tell me I can put it anywhere above that. What are the reasons I said you need to determine depth? What reasons? Somebody tell me what I just said just now. What are the reasons I said you pick a depth for your foundation? Discrepancy. Yeah, but that is just a description of my question. You have not told me the answer to the question. You are still not answering the question. The answer is no foundation should be at the depth not more than 2 feet into the new soil. I mean, say 2 feet, 2 meters, or 6 feet into the new soil. If the soil layer is very thick, 3 meters, 10 feet. So the first condition is no foundation must, or the first rule, no foundation must be less than 2 meters into a top layer of a soil. No. You say no. Well, and there's no other soil anywhere. Like I said, if there is fuck up, at that time, we treat it. But it's a rule of thumb. You can't see it in textbook. Some textbook will write it too, but it's a rule of thumb. If you're a professional, you know that there is this inconsistency in error and the rest of them in the log. That's on one side. I said you can also not put in what type of soil. Okay. So now, that is in the background of our head as we are designing this pie. So this clay, our life is easy. We are looking at the steep soil. That's why we are picking the sandy clay. Abi? So the sandy clay, what is C? C equals to, did they give you? They give you C. They did not. They gave us N value. What's the average N value there? You have 2, you have 12. I'm sorry, you have 5. Why am I coughing now? We have 5, 12, 16. Well, I don't come. Number 1, I've already told you can't do 2 feet into it. You can't do 5 feet into it. And this is another reason. Yeah, I didn't have that one. The reason is this. Look at the value there. It's low at the top, which is 5. Why is it low? Because in life, in nature, there is no direct line that says a perfect line between 2 different soil. They will mix. So the top layer, you can see the soft soil will mix to the top of the stiff clay. So the property at that point, at the boundary, will be in between the soft clay and the stiff. That's why you have 5 there. Those are the reasons you still have to go further into the soil, so that you can be sure that I am in the soil, NEIB. Those are the reasons I'm telling you, give that 2 meter or 3 meter from the beginning of any soil. So if you are looking for the average, you don't consider the top side. And because if you go back to that SPT table, 5 cannot be representing a stiff clay. Can 5 represent a stiff clay? It's supposed to be a soft clay in another place. Go back to it. We'll go there. We'll not go there. We'll still need that table. Is it? You understand it? So let's go. So that means that we are left with The other table we have 18 and what? 18 and 20 something. Go back to the question. We have 12 and 16. Okay. So let me determine where. And 10, 15 is at what feet? What's the depth? 12, that 12 is at what depth? 15. So I want to pick that as the minimum embedment for my foundation. That gives me average between 12 and 16 actually is 28. That's divided by 2, 14. But anywhere around that 12 is safe. Do you understand that? Because of that table again. The stiff clay starts with what depth? What value of N? 9. That is that. So I have the density of the soil, unit weight as 118, Abi? Pounds per cubic foot. Is that not what they wrote in the question? Something that density, unit weight, that 118 is pounds per cubic foot. Pounds per cubic foot. You know what that means in symbol? They just don't want to write it. Look at it. LBFT cube, which is equivalent to kilonewton per meter cube in metric. Is it coming clearer and clearer? Or we are still confused? Did you order the food? Have you ordered the food? Is what I'm talking about? Any question? Are we lost? What actually do you say challenge at this point, up to this point? What do you think is making it difficult for you to be able to solve this one? You don't know what PCF is? Or you don't even look at it at all? But they are very smart. You can see they did not. They just give you the extension is they only give you a length of how many anyway. They already give you 18 feet. Abi, what is total length there? 16 plus what? 16 plus what? Yes, now the cap now is still below ground now. Can't you see that from the drawing? So that's 21 feet. So that's why I'm walking around that place. You can see I just decided I'm not seeing the drawing. I'm working on the soil property yet. So you just took me ahead. So we need the soil property. We have the density of the soil now. And then we need the cohesion. Where do we get the cohesion from? Our table. SPT table. Go back there. We pick a value of 15. We go back to the table. He don't cast. What is it? Do you think how long does it take him to bring? Okay. Now we need to get the shear strength. Abi? We need to get the shear strength, is it not? Now we have picked an SPT value of 15 for Steve. What do you think it will be? Any figure? 1,850, 18, 19, even 2,000 can work. So this is omega, then C equals to 1, 9. This is pounds per square foot, Abi. Pounds per square foot. Any question? So soil property is out from the log. Soil property is out from the log. Who doesn't understand what we have done at this stage? So this table can go to rest. You can also confirm the unit weight that is within the weight for Steve soil. The unit weight given is 118 and the minimum there is 115. Though it doesn't really matter, but at least that can help. In case they didn't give you the unit weight too, you can get it from this table and to be fine. So this practice question seems to be more practical, right? So are we okay with the... Okay. We'll wait for you to catch up. Go through and let us identify where you have challenge so that we can take it before we go to the next stage. Unfortunately, this training is actually not for design. You are now taking it as if it's an opportunity to design. We're supposed to just talk and fla, come up for this side. Objective. But it's not a major objective. It's a minor objective. The scope is to know how to install. So that I can get your certification and be installing for people. This is not something you give anybody to do. So you need to know all of that. But this will help if you are a designer. An installer does not mean the person that will be turning the... You don't have to be the one operating the machine. So this is what I want to do. That's why we selected you people. It's not because you are going to be the one to operate or put pin or carry any helical anchor. No. But because you are going to be in charge of that installation. So that's why you need to have this training, get trained, get qualified, and certified. So that when you are doing it, you know what to do. You know what to do when things are okay. You know what to do to make things okay. And you know what to do when things are going the other way. When it hook. And if somebody come and say, what is going on? This is not turning up. You can easily talk technically to defend or explain what is going on.
One thing that the major quality check they did, there was just the alignment that they did. So is that the only checks that is supposed to be done at the point of installation?
Away from the alignment, we check the torque.
The next one is the rate of penetration or the rotation speed. RPM. So if you run too much, you will create loose soil and then you won't have anything. And if also not penetrating well, you could turn to CFA. You could cut soil. So it is important. Rate of penetration or RPM or both. As far as we are on this one, any area of contest. The man went to toilet. Who has any other reason or any area I want to contest?
During this helical pile installation, what if there are things like rocks or blocks under the ground while installing?
Wait for that one for after lunch. Wait for it after lunch. Things can go wrong. So many things can go wrong. And there are ways out. I can tell you, but you will not appreciate it if you have all those lists. Or are you in a hurry? You are not installing today now. It's part of what we are going to do in the afternoon. If you do get rock, you get rock now. You get rock, you no go. That's the first thing, you no go. If you get rock, it will not go. It can spoil. It doesn't have to. It can if you didn't notice on time. Or it's so bad that your blade don't hook up. It damages the machine. It can damage the driver, the motor. It can damage the auger itself. I mean the helical anchor. It can also just bend it. The first thing you do is try and come out. You bring it back out. And probably you will have seen bent. If the thing is bent, if it's what you can adjust, you adjust with hammer and the rest. If you cannot, that is done. If it's something you can cut away, you cut and you continue. But you will not continue at that spot. You move away. Okay. If it's something you can reach, like excavator, you can dig. You dig and remove. What else? You deal with it. You come back to your designer and say, well, I don't come. What's the way out? One good thing about it is for every issue, there's a solution. Angle could change. That's the solution. If there is no other way to go, you could change the angle and see whether you go out of the rock. But if you still not able to go, we have to find a way. That's what we talk about. In difficult soil, you can't put any foundation. If you don't have any other soil, and you have to put foundation there, so many solutions. So many. That is one, just one out of plenty. So. You know what the pitch of analysis is? What's the pitch? The pitch is always, the blade is not entirely horizontal. So at the mouth, they open it up. And it's 7.5 inches. How do you call it? 75 mm, 3 inches. So if you have a stone that's bigger or up to 80% of that, of course it will not go. You will hook there and that's the end of the work. But then you have to be in the ground before you see it. But if you have done soil test and you find it, you can also, they can increase the pitch. So that's also a solution. You understand? So nothing works everywhere. But engineers are why we're engineers. We have to prefer solution. So there are so many reasons we got to this point on this design, on this project. The first initial was like, okay, let's use a long pipe. First, there are structures where we want to work that we cannot remove. If something we can remove, we will have just used dead man anchor. Dig the ground and put dead man there and tie and rope. Everybody go home. But there is a very critical facility, which is the sewage plant. You cannot remove. The other side too, there are structures, but those ones are canteen. And that's the first part of our work. We have to remove those canteen so that we can dig ground. So the first solution is, can we take away the thing that is blocking the thing? That would be the cheapest one. Okay. So the first designer, they proposed like, instead of, because a 12-meter sheet pipe, they said instead of anchoring it, let's make it longer. So they proposed about 25-meter length,
which is okay. Unfortunately, it's concrete. And concrete can only come in 12-meter length. You can't join sheet pile. They don't join sheet pile because it's all about bending and rotation. So that option becomes impossible. Everywhere we go, even manufacturers abroad, can you join this? They say no, 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 no. And even from calculation. So we are left with so many options. And there are also still so many options. But we just pick this one, which happen to be the fastest and also reliable. There can be grout, normal just grouting. Just drill it, pour concrete. That would be a little complicated. We're also trying to avoid putting a foundation under what we are trying to, because that sewage plant it's on shallow foundation. You don't want to put something that will also go and disturb, even though you didn't remove it, I don't know you want to damage it. So we don't want to do replacements. We don't want to do replacements and courage. You know what I mean by replacement? Common soil. Put something. So we want to do displacement. So the more we are forcing things in, the more the soil is also improved. You see why I don't want to go to that topic? It will take us away. But go ahead. Go ahead. I have not actually heard you. I'm just telling you why we shouldn't have gone at this class, because there's a class for that. You still want to ask your question? Ask. We have started. Ask. Mm-hmm. Yes. I just said that we cannot join sheet pile. Why? I also gave the reasons. Why? No, it's all about bending. So the bending requirements, sheet pile is designed more of bending, not to carry load. You know, they carry any load. You won't bend. You won't fall. So when you put a joint there, and that fall is permanent, at least from the soil, the backfill soil, even though you are not putting load on it. Naturally, for you to have a freestanding wall, one side water, one side nothing, one side soil, is constantly loaded. Okay? And then at the end of the day, you don't want a situation where your joint has rusted. Just your sheet pile falling. Okay. Where are we? We're waiting for you. Say you don't have any question again? You catch up eventually. Okay, let's continue then. So on the soil, we have been able to get the soil parameters. We've gotten the unit weights. We've gotten the cohesion for calculation. So now, this question has proposed an helical configuration for us already, which is how many helix? Like I said, it's at the depth is here in the drawing. From the top, we cannot dig ground and go and install helical pipe. If it's possible, we can actually. But what still matters is that the top of the soil remains the top of the soil. It doesn't matter where the head is coming from. Even though the head is here, this is the top of the soil. Here they call it 3 feet, Abi. 3.5 feet. Abi? Why this side is what? 19. So at the end of the day, the depth of the lower is 22.5. You getting me? That's what it is. You look at it. Is it within the soil? Yes. Is it within dangerous soil? Is it within dangerous soil? No.
Okay, there looks no. Steve, no. Steve, sure.
So now, in this design, we are getting the answer. They have determined the pie. They have chosen the pie they want to use. So now walking back, now we are walking back. We have the answer, we now go back to the question. This now is no more a design, it's an analysis. I don't know whether you understand. Design in real time is working from simple, known to unknown. Analysis is from known to, I'm sorry, from unknown, the main design from unknown to known. While analysis is from known to unknown. This design has been done by somebody. Your job is to check, is it properly designed or not? So you see the same step we have been using, you just juggle it. So you already have this helix, which is, the bottom is how many diameter? 8. This one is what? 10. This one is what? 12. Okay. What is the surface area of this? From that table 1. First table. You can see that we're starting from the last answer. 0 point in inches now, in imperial, because all our units is imperial. 8, 336, and 10 inches. This one. Add them together. And they are all in the same soil or not? Are they? 1.638. That is for one side. But before that one, what we could have checked first, these 3 blades, are they in the same soil? We don't know. Do we know? We don't know, because they didn't tell us. But we know that this one should be 3D away from this. Abi? That become 30 inches. This one to here. Abi? Because this is 10. 10 inches times 3. 30. Abi? We are here to here. First. Between this one, we never reach 12. Yeah, this 10 is higher than 8. So between here and here, 36. Add all these inches together. How many feet is that? How many feet? Divided by 12. 66 divided by 12. That's about 5. And the remaining how many? 6. 5.5. 5.5. You are not there yet in mathematics. Abi? You agree? You have to be fast in mathematics. 36. I mean, we have 30. What's the total again? 66. Divided by 12. Times 5 will give you 60. It remains 6. 6 is half of it now. So it means that the topmost helix is at what depth from the top surface? From 19.5. So it's what? 14. Check, go back to your log. 14 is one type of soil. Go back to that log. The question. It's within the same clay we are looking at. So we are good. Right? So it's good that we use only the property of that soil. If we were to be in another soil, the calculation for determining capacity will be based on the soil where it is located. Do you understand that? You can see I'm working now. I'm not just going to calculation, I'm also checking. So, okay, it's within clay. So this soil property works. We are doing analysis. Any question at this point? Go ahead.
Looking, thinking we're going to give him mind. Look at the
Okay, I was looking at it from the perspective of considering the blade based on how they have designed it here. You know, like for the first blade, they placed it at 20 feet. The second one, from the section here at them with the log, is a continuation of the extension of the rod. Okay. That was how I was looking at it, but
And in any geotechnical report, or when you're working document, they won't be side by side like that, except you put it yourself for illustration. So you look at them from what is on the drawing in terms of dimension. It's dimension that matters. Any other one? Yeah, bros, wanted to say something.
With regards to the chart, okay, with regards to the borehole log, or soil log, I was thinking the soil type is known already, and the three helixes are placed in clay. From the chart, from the log.
We know the chart is clear, or the log is clear, but that measurement did not tell us the depth of any of the ellipses.
Okay.
The drawing, the second drawing, look at it. Did you give you the depth where they are?
No.
You're also looking the way the drawing is looking. Okay. That's exactly what you are looking. You think they are the same, side by side.
No, it's not. You have to use what is in that. Please learn to look at drawing and learn how to interpret it.
This one is just the first check. It's within, it's a check inside check. Because what we want to know is to determine the soil capacity. Sorry, the capacity here, and compare with the soil, whether it work or not. You understand? So that confirms that this is here. And then we can get the total area to be this. We also have the other information. For, what do you call it? Bearing capacity. Abi? That is 1.64 inches square. Okay, that is that. Then the next thing you want to ask is that, okay, we know the blade dimension, we don't know the shaft. Or the question gave us the shaft. No information on the shaft capability. So we stop at that point. We don't know. All right. So the next thing is this. Let's now determine the ultimate load. How to call it? The design load. This soil, okay, is clay. So our QU equals A, C, and C. Abi? We know A now to be 1.64. If I go to secondary school. We know C to be 1900. And C is what? 9. You remember this? Give me. You know I got 27,000. 38,000. Okay. What I did to make this one 2,000. Multiply by this. Get 1,800. Make this one 1.5. Idea is need. 28. Keep. Abi? You agree with the keep? 28K. That's the resistance. Now, when we are doing our normal design, we factor by multiplying by what? Safety factor of 2. And yesterday, you remember when I said if you are working backward, you want to use the factor on resistance. What do you do? If this information has given us that this soil can carry this as the ultimate capacity. So we now have to determine the allowable capacity. So which is the opposite of what we're doing in the other step. So the allowable capacity will now be this one divided by safety factor. QU over SF. Do you understand? Two person, we have one person to carry one bag of cement. But I say 2 people go and carry it. So 2 people go and carry cement. Active English. I want to go passive. I know it's a big grammar. Nothing, there. Cement is carried by 2 people. You understand? You multiply when you are going forward. You divide when you are coming backward. Therefore, the design capacity will now be 14 kips. Okay. 14 kips. This 14 kips now is now checked. What is the load they want to carry actually? Is it higher than it? So geotechnically we are good, right? Your report will now be allowable is greater than design. Geotechnical check. Geotechnically we are good. So design is okay. But since they didn't tell us the strength to compare with in terms of torsional capability, if you stop here, you have finished work. But we want to show some level, provided you now say this condition under your limit of report of your design, when you're not writing notes, is only valid if this design, this confirmation or this analysis is valid on the following condition. If you go to torsional check now, so we have what do you call it? You go back to year 28,000 now. You understand? So QUT, you do it somewhere else. You don't need to put your calculation in your report. Equal to QT. Abi? What do you call them? KT. And this one is 10 in metric. Go back to that table. I mean that, you remember it's 33 for millimeter. For metric is 10. So the top requirement to install 28K divided by 10. Abi? I don't believe you guys are beyond primary school level. That's why I'm doing all of that. But Ross, I know you are lost. Are you? Hey, surprising. Praise God. Torsional check. You know that QU equals to KT. Our QU is this one. Look at it. QU. Not Q allow. Not Q design. You understand? So, and this is 28K, which equals to K is 10, 10T. T is 28K over 10. T is 2.8K, 2,800. So what shafts? Go back to the shafts selection table. I'm waiting to finish the note. Now what I'm doing is calculation to be able to finish my design notes. Bros, the head on the not scratch and I'm saying it don't blow. Is it blowing? Which one the torsional check?
When you make a design,
you have to put design note. Otherwise, somebody go and do something else. They will say now you talk say they okay. You don't understand. Now you go talk say Oga, now you license you as a registered engineer or registered geologist. Now you they go home. Or they will hold you to some extent. They will see who contractor. Because now the owner of the job will hold you. So can you talk, say this is okay? Why? Why? Don't tell me. You say, but you didn't check talking. Say, but you supposed to know now. Are you not an engineer? Why don't you advise? You go to council, they carry you go court. Go see hire lawyer. So that's what we are doing. And you remember the formula? KT talk equals to KT. You still remember that one? And it's that talk formula is for the ultimate capacity. And that's what we go for the ultimate capacity from soil. Do you understand now? Is it clear now? So, from the table, what shaft will survive that using imperial unit? 2,800. SS125. So, this my okay is subjected to two conditions. One, provided the shaft, the helix, the pi, as SS shaft. Because the method you use round, you don't concern you. You now say or equivalent. You don't come out for your head. They don't concern you. If they call you, you tell them. If they don't call you, you can charge them again. Or somebody say, you know what, I'm also an engineer, don't worry. We don't have square shaft, we have pipe. Let's use the round shaft. So that's going to look for a round shaft that has that equivalent. The second condition, the pi is installed with torque not less than what? Pounds feet. Now you know what it is. Oh, join. Your hand don't come out. This one they will not call you again. You have done your job. Instead they want to tell you to recommend shafts. Another money enter. Any question? Madam, are you now a confirmed designer? But you are close to it. So, any question at this point? All the pens are running. Okay. Yeah. There's a I think we have it. We did it. We use it in doing the counting. There is a angle measurement. There is to determine the angle. There is a device used to measure. You can do it two ways. You have a compass, or three ways. You come with a compass, magnetic compass. You have seen it in my office. You put it, it will show you. You can ask surveyor to do it for you. Okay? You can do it in your house and cut a template. Already you make your where you are putting your, what do you call it? Your car. It's already, sorry, your drive rotor. It's already a template fabricated. Just put it on. And you keep on checking along. If it's moving, you drop it back. It's capable of moving back. If it moves up, you bring it back. Like that. So how many percent did I say now? By using a compass, by surveyor, I'm using templates. No, on the field. So I've done the calculation. So no sure that I see at 20 degrees. Don't say they go another place. because you cannot guarantee it. You keep checking. That's another quality control check. You keep checking. Any question? All of that, we'll see it on Monday. All of this, we'll see it on Monday. I wanted to bring them here, but they are too heavy. But the person we want to marry, we don't need to go to our Snapchat page. You see, you have to see. Maybe another person. This is why Yahoo down. Make them say a man they propose to. Abby? What they mean by that parable is that wife you don't know, you don't date, you don't know him already. You don't agree wedding date, I don't pick date. So in the morning of the wedding, after you finish the wedding, you go to the house, they are bringing her. You can't they go look window. You see coming. Where is he? You are paid now, everybody is. So you need to relax. He's coming. But if you know agree come too, there's always backup. There's always backup now. Abby, no backup. See my dad look me say, child. There's always backup. The question is that you don't know what the backup is. And you cannot take me to court. You don't know what I mean. Any question? Any question? So, you want to say something? Who wants to contribute? And your salami has not got into the bus stop. Are you there, yes, or you are still moving?
Okay, situation where the soil is rocky. Rocky. Yes. Okay, so in that situation, can this kind of pile work? This kind of
But there are some rock if you walk.
okay.
You need auger and crusher. If you look at that, okay, let me show you. On the celebration too. There are specially made lead, what do I call it just now? Lead helica or lead section that is specially made for rock. Can you display this for us? Rock fit. You see him? See the mouth. See the mouth. But of course, not every rock. The guy go do this your carbine. You go break away. So you want to avoid it.
When you said that we can't,
You can't lengthen it.
yes. So what did we do in this our case? Okay. All right. Thank you very much.
Any other question? We can put to rest this morning session. If there is none. Is there any? I'm looking for questions to ask. So can we summarize what we have done? Let's summarize in the design so that we can go. Normally what we are doing is that, or what we have done so far between yesterday and now, is that for you to have an engineering design, you have to consider both geotechnical and the structural capacity of everything involved. Soil resistance in terms of soil with soil information, capability of your or the capacity of the helical pie based on torsional resistance. Those are the key, or those must be checked. Okay. Before you can say your design is complete. So it is important that if you look at all those examples we have treated, we look at the soil capacity, we also check the structural or torsional capacity. So it is important. So again, design is of two phases. Straight design from known to unknown. You also have analysis from known to unknown. That is, somebody give you, okay, I want to do house, so I get some pile in the house. Can I use them? This is the information of the pile, or you go there to go and check, like the last question. So that is not design, that is analysis. Okay, a lot of people do confuse them together. Design, you have basic parameter and you generate the big parameter and you recommend. From the analysis, something is done. You are carrying out a check to confirm the suitability. If your scope also in more than that, they say constructability. Oh, even we have this, okay, we'll get this one, or we go work, but we don't get machine, we go fit use them. You know the Nigeria. You know what I'm trying to say? So if somebody tell you that, okay, I've checked, mathematically everything is okay, but this one need the excavator, we get 3 pockets. He did, you know they. So I will say this one as for Bola. I'm going to look for somebody who go buy them. I'm going to go buy another one. I'll talk to the people selling whether they'll collect this one and exchange for us. Design can also come in that form. So it is important you have accurate soil information. The structural strength, you don't need to worry about it. Check with your talk formula. All the data for structural strength are provided and guaranteed by the manufacturers. So except you go and you go and produce it yourself, because you can also produce it yourself. I have produced a lot. All the one I've used, I have produced myself. But saving yourself the headache, buy from registered or certified producers. They give you warranty. They also give you technical backup. Do you understand what I'm saying? So it is important you have accurate, not precise, accurate soil information. It is important. And you also have at least a means, valid means of measuring torque. Those are the 2 takeaways. You must have accurate soil information. That's number 1. Number 2, it's even 3. Number 2, obtain accurate specification of helical pie from reliable manufacturer for you to be able to design. Accurate soil information. Product specification from reliable, accredited, known manufacturer. So when they say it's 14,000, it must be 14,000. When they say diameter is 14 inches, it has to be 14 inches. When they say the thickness of plate is ½ inch, make it not be ½ inch, what they say for my 3. You understand? And the third one, you must have a valid or reliable means of measuring the torque. You can't do it from calculation. And there are 2 known. From hydraulic system, I showed it to you, right? And then from torque indicator. Torque indicator are different types. There are mechanical one, where they count like this bear where they prick them, go back and down. There is digital one. You are competent enough, like the one we have is digital. Okay. RPM. I think that torque indicator can measure it. You can use your eye to measure RPM. Okay. But key, it is important. These are difficult things you need to have on ground. Torque indicator, accurate soil information, and product specification. They are key to design. You are the one, except your client tell you something else. You are the one, based on your design, who will now write the project technical specification. That this design, this is what must be, that will make it work. This is part of the notes I said now. So after the design, we now say, please use SS this. That's project specification. And I'll tell you, any talk less than this has to be investigated and tested. Now, I mean, right now, we have to test by verify before we do the other one. Do one and verify. Now, I mean, right now. Okay. The acceptance criteria. Now, I mean, right now. When I say me, designer, it doesn't mean Lawa, even though for this project, yes, I did. Okay. So, but based on all of that, I can go and sleep, because it is also verified by the manufacturers. So when we did all this specification, we now send it to manufacturers. Okay, we'll give you this length. We don't have this one. We have this one. They have owned it. Like this LACs, there are some people say, no, we don't have, but we'll get you this one. They'll give you the same thing. We don't get, there's something they always say they don't get again. They say, okay, the motto, the drive motto, they are the one who provided it based on the talks. Okay, based on this soil you provided for us and what you say you want to do, this is the size of the gear motor you will use to drive it, and we guarantee it. There's also part of a construction engineer, if you are going to be one, or you are combining it with your service in your company, you should be also to now say, after all this design, you need to go and buy a torque motor of this capacity. You need an excavator of this size. You need a skid motor of this size. If you are using a backhoe, you need a backhoe of this size. You understand? That's construction part of it. But the specification, it is the designer who writes the specification. That's why I didn't say specification is part of the requirement. Because it's after you are able to get all of that, you determine that. Good soil will give you information. Good soil information will help you writing a good specification. Good, what do you call it? Reliable manufacturer information will help you out. And then the rest is manual. You can see that we don't need software. You can do this job you can make the design in a day without the use. Believe me, what we have done is exactly what you will do. The only thing that is we didn't do is how did you get that 70 kilonewton?
I hear you.
And that is from your analysis of retaining wall.
Hello, Adoga. Over. Adoga, you with us?
I'm with you, President. I'm with you. Let me unmute. Let me mute.
Okay, no problem.
So, that is it. Anything we are supposed to say, we have not said, or is there anything we have said we are not supposed to say? These are statements from my senior. After a meeting like this, we'll ask you, since you are refused to say something, okay, is there anything we are not supposed to say we have said? Me, I can point to one that we are not supposed to say.
Good morning, all. I think this training has served as an eye-opener for me personally. In fact, when you mentioned that organic soil is a no-no as far as construction is concerned, I was a little bit wary. And you later came back to say in engineering, the reason why we actually exist is to proffer solutions. So my concerns now is it so bad that engineering cannot proffer solution to a remedial issue, yeah, yes, so that because soil or land, so to speak, is getting scarce by the day. And people are beginning to improvise. Yeah, so I don't know if you can shed more light on that part.
Again, it is confirmed that organic soil is a no-no for soil, and I've given for foundation. I've explained the reason, but all of that are because there are other soil around. I don't know where you understand it. It's because there are other better soil. If there is no, I said, if there is no solution, we will treat the fuck up. That was my statement. So there are solutions, a lot of solutions to it, but they don't come cheap. They are expensive. Some are time consuming. Do you know what it, do you know what it, do you know, you were in Bonnie for some time, or you are ready when they say preload. That's one of a solution to a bad soil. And it's easiest way or cheapest way, or one of the cheapest way to work on organic soil. But it is time consuming. So I now can't know how cheap is it if you are putting money or value for time. But for a project that you are not in a hurry, you are not losing anything. If you know that this project will not start until the next 20 years, but you have the idea and you have intention to do it, not that you are losing money for not doing it, but you just decided that this is when I'll be ready for it, for other reasons best known to you, you can preload the soil. Okay, put some load on it, and it will take time. It will consolidate the monitor, the monitoring, and the rest of them. And by this soil information, characteristic, and design, you have an assume. And then by the time 20 years come, you just do 1 or 2 tests to confirm what your objective is. If you met it, you're as good as that. That's a solution. So when you say everybody do preloading Bonnie, they do for LNG. That's what they're doing. Because they have very bad organic clay around that facility in Bonnie. That's a way. The crazy way, you know what? Fuck it. Excavate everything. Put another sand. No be my money. It's a solution. Now, you can also improve. Sometimes we have to inject grout, inject chemical into the ground, and then it reacts with the organic system, more or less killing them. Let me use that word. Quote and unquote, you kill all the organic thing that can cause problem. And you turn a black soap into a detour soap. So they put chemicals, they put different chemicals. It could be epoxy, but basically they use calcium, what do you call it? My head is leaking right now. I think it's you put lime, all of that, it reacts, different combination, and then it's improved. You can also do deep mixing. You mix them like pie, like CFA, you read down. You pump bentonite or this lime, we'll say, depending on the content. But before you do that, you have to do the chemical analysis. Now you have to rely on chemical analysis of the soil to be able to know what to use to treat its fuck up. People are beating on dump now. Now so many dump in Lagos. Where the look house no they again. You look for where they dump for Port Harcourt. Is there any dump site? Look what that yes. If land don't finish, in a field now, we go hard, but we go do them. But one good thing is that there is no place where you have bad soil from surface into the mantle. You know what the mantle of the earth cross or to the come. So before the core is mantle, you don't come home. The earth cross. There is no way you have organic from zero to bottom. Even the condition, the pressure, temperature won't allow. So the worst will be go to have a 200-meter deep pie. It's also a solution. The question is that whether it's worth it or not. So side by side, time, uncertainty, We have seen where people have improved soil using soil column. They don't want to use pie. At the end of the day, the house still go one side. So you did it because of the uncertainty, or probably people didn't do it well, and they still go back to zero. It's as good as you didn't do it at all. So those are the reason you just, you know what, let's just, I will never go buy land around that place where you talk, no matter how, even if surrounding that one remain. I better stay in the hotel, or I go my village. Because I look at the cost, maybe now this my batch I want to build, I can't use 100 million to do foundation. You understand all of that? That is why we said it's better that way. Even when Nlng as big as they are avoiding it. By doing preload. They can easily not do preload and give contract or beggar or whatever they are. Give us special solution and let's solve it. No. Because the soil is bad. It's as simple, and they don't want to do pipe foundation. It's as simple as that. It's not vibration, it has not to do with vibration. Pipe foundation or deep foundation is expensive. And this is like a pie. Nobody knows that time. I'm not even thinking of it. Yeah.
Most of the foundations are on pile. Most. But your money is not like that because it took time
Up front, they fill the place 30, 20 years. I don't know how long it is. So everything remain okay. That's it. If the house wants to, if you don't settle, maybe you don't settle 2 meters already, don't finish. Settlement don't finish. That's the end. It becomes normal ground. Any other one? Yeah, we have the installation in the afternoon, and then we can all go home for a weekend. Tomorrow we're supposed to do the practical, but we need to set up in the yard, so we do Monday and Tuesday. I will write name and I forgot. We need to write clearance for you at Nlng for temporary 2 days. For those who doesn't have a badge to come inside. So I'll do that now. After this, I forgot. So I can get the clearance for you guys for 2 days. So after the class, bros. After the class. So, do you have any question? Anyone? Okay. In the absence of I'll be online.
Is Adoga still with us there? And
I'm still with you.
okay, so you have any doubt, any question, for clarity?
No, I'm okay. Like I told you yesterday, I said that the participant is just doing the great job. His explanations as to how he's running the show here, it's very clear. It's okay. It's okay. If there's anything, definitely we'll raise it up and then let him know.
Okay,
Yeah.
so just for a reminder, this is an awareness session or a kind of, how will I put it, trying to give us an insight into helical pile installation. But
Yes.
the facilitator has done even beyond by trying to give us little tips on design and analysis of helical anchors, decisions to be taken, what to look out for. It covers even design, QAQC, and even the cost. Safety also embedded. These are things you have to consider before going into such. So for even supervision and assurance purpose, we also can say, oh, with this you have done, this is okay and this is not okay. So that is the essence. But he has really done justice to it. He has gone out of bounds to make sure the class is carried along, and even giving exercises where we also have people that can say, we can talk about design. So it's a good one. Alaji, thank you for thus far. Thank you.
Thank you everybody for being here.
We'll look forward for a continued cooperation, and anywhere we think we need to improve, let us know. Don't be shy. With that, we can say let's go for lunch. Thank you. It will just be a relaxing one. This is the purpose of this. This is the actual deal for this training. Installation of helical pies. I mean, we've said a lot, and I'm sure you already have some idea in your head, so we'll not bore you with too much talk. We are going to just pick 4 items to deal with. The equipment that you need to install the pile, all the materials that are involved. We'll discuss how to install it. We'll take 7 basic steps for its installation, and then the standard, how to call it, the installation procedure or the sequence. The sequence that you have to adopt before you can install an helical pile. We'll do that, then we'll discuss what we were talking about in the morning. Things can happen, challenges can come up. What will happen? How do we deal with it when they happen? Shit can enter fan. When they enter fan, we go reach everybody. Happy? Then we have time to watch some video to have idea of what it's looking like. At least that's the alternative to practical for those who will not be able to attend the practical class. So we'll take questions and then we'll go for the weekend party. We all go home. Okay, basically we have it can be installed with all kind of equipment, all kind. The first one you are seeing up there is mounted on a skid. A skid just like a railway line. So it travels, as it is turning, they push it. They are pushing it hydraulically. There's something like a jack pushing it horizontally. It turns, they push, and it goes. That's a skid. The other one you see top right is on the ground, and there's a separate power pack. That power pack is like a small welding generator. It supplies hydraulic oil to the drive head. So, I mean, these are not where we would install it, but if you want to do it in your house, you can do all of that. Okay? You can also have as an attachment. The next line, no pointer here. Can you see my mouse? No? My mouse cannot show. Is there? You know the one I'm talking about? 1, 2 up, the number 3 down. That's in the middle. The first one in the middle. That's how do you call it? As an attachment. I can attach it to any machine at all. Payloader, even a truck. That flat side on the right is where you mount it. You bolt it to anything at all, tractor, and then you give it power, hydraulic power. That hydraulic power can come from the equipment you are mounting it on, or you can also have a separate power pack on the ground. Okay, so that is an attachment. Then you can use all kind of diggers. The other one in the middle was the skid, what do you call it, bobcat. Who have seen it before? It's a small, it looks like a small payloader with rubber tire. That's a bobcat. Some of them are on track too. It's a small equipment. If we are doing, maybe we are doing it in a warehouse or like here. This is where you have low headroom. Low headroom in you have limited height, you can walk. So this kind of equipment you mount it at. depends on site condition, availability, and sometimes choice. If you have to hire, costs. You don't hire a big excavator where you can use a small one. So anywhere you can get, I know what hydraulic power is, just like generator, you plug it, the power. When you finish, you remove it. So at least that's all about it. In the site, when we go for the practical, we are going to be using an excavator, okay, to install it. That's the plan for this project. All right, now let's break down the parts again. I mean, you have seen, what was that one with blade on top, on his body? That's the helical pipe, but what is it? I mean, how to call it now? The trade name now, is that the lead section or what? Or an extension? That's the lead section. But there's an extension there too. The one on the left is an extension with blade. Sometimes you need 5 blade. You cannot have a lead extension with 5. So the lead will have 3. The first extension will carry 2. And this plain extension, they call that one helix extension. They call this long one plain extension. That's the one they put as a square shaft anchor. Does it make sense? All right, that is the basic. There are a lot of things, pin and all of that. Okay, but those are the basic materials you are going to need to have an helical pipe foundation. And then this is the drive area. You can see the hydraulic equipment is not shown. Okay, hydraulic equipment is what now? Excavator. Then the torque indicator, that's the one that measures your torque, and sometimes I think it measures RPM. So your problem is relieved. Like I said, on Monday you will download. It's a Bluetooth device, so you can be in your house and you can be getting the result. The Kelly bar is the direct component on top of the what do you call it? Torque indicator. That's where it's a square pipe. That's where, if you have seen the motor before, you know it has a square shaft. You enter that Kelly bar adapter. And then after the torque indicator, you also have a drive head. That's one they say is having a locking dog assembly. It's a drive head. So on top of indicator, you have the caliber adapter, and at the bottom, you attach the drive head. That is the head that goes directly onto your helical pipe, either the lead or the extension. So before you do start work, all of these parts must be on ground. You must know how to assemble them, and then you should be able to assemble them. And like I said, you are not going to do the one to assemble anyway. But at least as a lead or supervisor, you should make sure when you inspect, all of these are available so that you don't get to site and say you forget pin or you forget the helical itself. Any questions so far? So just have an idea of what they look like. You see them. We'll see them on Monday. We'll see them in some video now so that it's stuck to our head. Does it make sense? The drive head is the same thing they are calling torque drive wrench. Okay? Or na grammar. Or driving cap. That drive wrench is the driving cap. And the square you see there is our helical extension or whatever it is. Hello? Are we here? You are still thinking? Okay. Any questions? This is straightforward, Abi. It's better seen than imagined. Okay, the other parts, I mean, not necessarily common for every type of helical pipe foundation, but it's peculiar for this work we want to do. Okay? It's not in the previous slide because it's not part of basic. If I'm doing a foundation for a house, I have different accessories. But I put attention on this one because this is what we are going to do for this project. So you are going to see a locking pin. That's what they call dog pin in the previous And you know the work of the pin. It secures the connections so that it doesn't break off and it doesn't injure somebody. Then the threaded bar. After completing, if you look at those anchors, they don't have any connection at their hand. After you have finished your installation, you now want to connect it to your tension bar or whatever it is. You will need a threaded bar. Sorry, threaded rod adapter. Can you off this light in front there? So that you can see the drawing. Look at the drawing, not the photo. The drawing on the left. It look like spanner extension. Abby, it look like a wheel spanner. One side of a forehead. Can you see it up there? It's labeled threaded bar. Do you know where I'm talking about? On the drawing. Yes. It looks like normal, those on way trailer people, they can't lose their tire. It goes directly on top of the end of your anchor. You put a pin, and at the other back of it, it has a thread where you can bolt knot. That's why they call it a threaded rod adapter. Then you have the threaded bar or threaded rod. That goes into that one. And then you have the plate. The bearing plate is what you are seeing in that photo. And the threaded bar is the rod coming out from the plate. Are you getting it? Or you want to forget about it? Okay. So, of course, you need both and not. I mean, not rather. You don't need both, not. All of this one I listed, and like I said, only useful for a tie bar anchor, a tie back system, because this is the focus of this project. If you are dealing with a house that's a bearing plate, if you want to lift a house or you want to do underpinning, there are brackets that goes on top of it. So each task has specialized accessory. But the basic is what, any question we have discussed. Somebody want to add, subtract, clarify. It's pretty easy, right? Okay. What are the 7 basic steps, or the basic steps? It doesn't matter. This number, I name it. It's not like it's a Bible. To somebody, it can be 15. And to some people, it's just 3. But at least, as far as I can remember for now, these 7 basic steps are the steps that are involved in the installation of helical ample. I mean, of course, after doing our design, what did I say? You go to your construction manager or construction engineer, you all do the material takeoff. Abi? You are able to estimate how many helical you need, how many accessories, how many threaded bar, how many, all of those things. All of them. Then you estimate, you make a requisition, and they provide. And as a common sense thing, you provide extra for like 10% or 5%, so that anyone that goes wrong, you don't have to wait for 2 months to import them. Since they are going to be producing them for you, so you better produce in excess. And when you are bidding and quoting for it, personally or for a company, you include those extra in your cost. You are not going to tell the client that you are buying extra, but you know that you may need extra, because it's not like you cannot get angry and say, I'm going to buy it. It's not in ShopRite. Mm-hmm. Mm-hmm. Mm. If you are in a slope, are we on a slope? You don't need number 6 now. Jesus of Lagos. No, there should be, because we are putting an angle and we have an inclination meter. When I said in the morning, what do we use to measure the angle? I listed a compass. Surveyor can do it for you. You can also have a template. So these are decisions you will make before you leave your office to site. What you want to do. Does that answer your question? Okay. So after getting all your materials available, what do? Everything's on site. Surveyor has set the point. You know where the pipes are coming. So you attach it. You attach every set, as you said, to the excavator. From excavator, you pick the lead, the first auger, which is the lead section. Then you drive it down. Driving it down is, it's not like you turn with your hand. You just pin it down, turn it a little bit so that it can stand. And then you bring the machine on top of it and rotate it. We're already in number 4. Any question at that as at there? Can we proceed? When you rotate it, it gets to bottom. If you need to add or extend you put the extension as necessary. Whether it's going to be an helix extension or what? What's the other extension? Plane extension. You keep on adding onto your design length. Now we have 17 meters to do. That's 56 feet. You add until you get to that point that is design, or you got to the refuser. What is refuser? When it's not going again. How do you know you are at the refuser? The torque indicator will tell you are approaching the limit of the bar. So you stop. If it is within 80%, 85% of the design length. So for example, our design length for that one within the demolition is 17 meters. What is 80% of that? Or 90% of that? Or 85? Pick a number. Let's assume 80%. 80% of 17 meters. 15 meters. So if you're at 15 meters, we can assume, and it didn't go again, or you decide to stop because your torque indicator is giving you an alarm. You can assume that you have done the design. You are within design limit. Nobody will charge your money as a contractor. So you don't have to overwork yourself. Just because you feel that if you don't get to 17, LNG will not pay. At the same time, when you are working on site, you have to keep to contract condition. So if you are around that 80 meters, it is assumed that you have attained the length. So you don't need to sweat. But if it is stopping at 5 meters, we will have to raise alarm. You have to find out. If it is an EPC, that is, you are the one who designed and you are constructing, you are in trouble. But if you just come and construct, you go to the client, it's in Ogrigo. What about restriction? There is no refuser. It's the talk that will tell you refuser. Because refuser means you know they go again. When you know they go again, you go increase the power. You go to increase the power until you go to, as you increase the power, you go to check your torque indicator. That is not your problem first. You first, if you know Grigo, you try to increase the torque. Put more power for the machine. Fire up. As we're talking for side. Fire. And you are looking at torque indicator. So if at the end of the day, you refuse to go, or go a little more, and you reach the limit of your machine, you have to stop. You now begin to investigate why it didn't go. That is when the length is below 80% of design. Do you know what I'm trying to say? Hello? You are lost. So if your design length is 10 meters and you are 8 meters and it refuses to go, nobody will worry. You don't want to investigate anything. You can test to confirm that it's meet up your requirement, but nobody will tell you have not done the job. But if you design a 10 meter and adjust 2 meters, you have this refusal, you have this obstruction. First, you have to raise alarm to the client. If you get to the length that they give you the contract, you go stop now. You go stop. It doesn't mean it has failed. The talk. And money don't come with that now. Additional work. They will just say, no, go and test. If you test, because at that time you have to test. Tests become compulsory. Even if you do part of your contract before. You have tests. If you now test, it meet up the load you need, it's okay. Even though you have a low torque. You understand? Or, you no agree do. You say put more. Then you order another one. You charge them in dollar. Okay, this is no delay, machine delay, overhead, money. They say carry them by the plane instead of ship so that I can reach quick or join. Abi bros. Contract value increase. Okay.
Hello, guys online. People online. Is Nzube there? Adoga. Can you please mute so we know we're together? Unmute, I mean. Hello, Nzube? Maybe just logged on.
And I didn't know it was there. I was measuring value because I'm a measurement man.
Then I make it. Eh? But she logged on and let me just try and then.
Okay. Let's proceed. I will shoot back to the slide. Where are we? I've wandered away, right? You don't know where we are. Okay. Keep on adding extension as you get to the design depth or refusal, anyone that comes first. Okay. Then as you are doing that, you keep on checking your alignment. If it's a vertical one, check your inclination, orientation. Angle may be correct, vertical angle. What about on the horizontal side? So you check both. Surveyor will help you do all of that. And if you have a template, it will also help you do that. So as you are advancing, let's say in every extension, you check, correct when it is necessary to make sure you have aligned pi as designed. Any issue with that? Of course.
If the vertical angle is correct, does that not imply that the horizontal angle is correct?
If you have a pi spacing of 3 meters, if you have pi spacing along your wall as 3 meter interval, yes, you have a vertical one correct, 45 degree or 20 degree, perfect. What about if it tilts to one side? It means the spacing will reduce. It will reduce on the upside and 70 meters away. You can go and jam the one coming next. Do you understand that? If a small angle on at the starting end can make your two got to be in one place. Do you understand what I'm trying to say? If it tilts a little bit and you have a long design length, and this one is also straight, or God will punish you, that one says, tilt, go meet them. So at the end of the day, two of them jam. You think on the upside, you are going to see them 3 meters apart, but where it's supposed to do the job is 17 meters away, not on the upside. Of course, project will tell you allowable deviation. 75 mm is allowed. And good thing is that you have to tension it. When you tension it, it will straight. That's a fact. By the time you tension it, if you have a small deviation, before it go begin carry load, it go fall straight himself. We'll see all of that when we do the testing. We'll deliberately make it bend, and then we'll try and jack it up. I hope we'll have the time. We'll have done a very bad bend too. You see that by the time if you put it bend like this, and you are jacking here, by the time you jack here, if you want to straight, you find out say your pie is out of the jack. Okay? So that is that. Then this process, you repeat them again from 1 to 6. You keep on repeating them at every piping location until you get to refuser or your design length. Again, anyone that comes first. Any question? Any question? After all this thing I said, now we'll follow step by step. Step by step. If you don't do one, you can't do two. There are two different things on the last time. In this case, it's step by step. You have to do one before two. You have to do two before three. Do four and like that. There are 8 basic steps. Again, these are just what is coming out from my own head. Tomorrow it can even be 10. Even before we finish this course, it can be something else. Okay, but these are basic. You can add, you can subtract. Based on site condition, based on job requirement, and whatever challenge that comes up on site. Of course, you have to attach your equipment to or the lead auger, that's the first one, or the lead pile. You align it because somebody, like a surveyor, will have marked the ground for you where the pile is coming. You put it on that position, and then you drive down. Put the pin, do everything you have to do, then you drive down. That must happen. If your length is exactly as you pick the lead auger, work don't finish. If you need to go deeper or longer, you go to 2, you add the lead section. And you keep on adding, function 1 to 6, until you get to design installation grade or refuser, anyone that comes first. And the third one, if you need more extension after getting to the depth, you stop and remove it from the... you cannot put something when it's turning. Though Nigeria can be very funny sometimes. You say, maybe the machine know they off. You know it's possible. That's something. It doesn't have control again. Maybe the operator will not tell you that it's control. As you start the machine, that's how the thing they work. Normally it's supposed to power it before it turns. And instead of stopping to repair it, they say we can manage it. So we go lower the engine. So we go to turn small. How to put it inside. That can cause accident. You understand? And that is not accepted. So that's why I say stop the drive head. Not remove. You remove and stop. Yeah.
Okay, just for the benefit of learning, like the normal bolt and nut on steel structures, say you're using a 16 mm bolt, you have your torque wrench. When you use your torque wrench, you know that there's a chart for 16 mm. We have this torque for this, and when you go, you hear that sound, you know that it has come to. In this case, that we're using a motorized system, how do you measure the torque? Yeah, of the bolt.
Again, those torque value you have in that table, it includes every part needed for the job. So they have so bore a hole to tell you need a 16 mm. They have added, they have done a lot of tests over 50 years before they get to that value. So the boat they are providing also meet up that torque requirement. So that's why they're not using standard boat like 8.8 or 10.6 or 12 point something. They have made the boat to be able to withstand the same torsion. So at the torsion you're applying up is what you're applying to the bottom. So if the shaft is taking 200 Newton meter, the boat is taking the same thing. All right. And that's also part of the thing that happen. We'll buy boats, we'll buy extra. Somehow, we have people who are bowler. They come, they look up, they arrange them. As this engineer, they always arrange things. Boats no can complete again. Driver, Obina, my tiri. Go and buy me boat. Untested, you may be lucky you have a good boat. Number one, it has to be galvanized. If it's not galvanized, that will be the first place the thing will start to corrode. Okay, so you have to pay attention to every detail. Don't be careless with it. And as I said, always buy spare. 5 to 10% spare. It's not a bad. And you don't take everything to site at the same time. So that somebody will not vex. Security says if you are not paying on time, they can decide to arrange. One bucket of boat is a lot of money. You know? So it's not something you just joke with. So you pay attention to everything. All right. Any other one? Okay, the next one, basically, because we don't have time, we need to be a little bit fast. Same, after that, you attach the extension section to the lead section with specified hardware, which is the boat we are talking about. You keep on doing it. You monitor your torque. You also monitor what again? You monitor RPM, the rate of revolution per minute. You also measure penetration. It is expected that when you turn it, you know what when we say 1 revolution, you know what that one means? And when you give money to your wife, I say turn, now check. When you go around complete, face come back to the same place. 360, that's 1 revolution. The gap between the two plates that time, which I call pitch. What did I call it? I said it's 75 mm, 3 inches. The mouth of one plate. Do you remember? Want me to go back to it? You understand what I mean? Don't worry, look at it there. Don't read, just look at the picture. Look at the helix, the plate, there's a gap there. That's a pitch. Do you see it? Everybody's seeing it, right? That is 3 inches standard production. 3 inches, 75 mm. So it is expected that by the time you turn this boat you are seeing on the left, by the time you come back to that position, we expect your pie to not go more than exactly 3 inches. Down. That is rate of penetration now. We are now saying 3 inches per 1 revolution. Some people will say, you know what, let's keep it as 80%. That is IBC code. You don't need to go, what's 80% of 3 inches? That's 2.5, Abby. 2.4. Wait, oh, yes, no. 2.4 inches, that is 2 inches, 4/12 is 1/8, 2.5. 2.5 inches. That's 80%. Yes. 4/8. Because they use 1/8. The subunit of inches is 1/8. Between 1 inches and 2 inches, now 8 division the inside. So now when you say 8 divided by what do I call it? 7 3 inches. Waiting go 3 times, Abby? No. 2 times. It remain what? It remain 2. So the 2 will be 2/8. So that's 1/4. sorry, quarter, 1/4, sorry, not half. So you need, by the time you turn it, you expect it to go 2 inch and quarter into the ground. So you see the blade is small. You understand that? So you monitor that, you keep to that. If you don't keep to that, what will happen is that you either begin to cut your soil and auger it, that is, you are now removing it. Instead of, these things plan to enter the ground as if nothing has happened. So when it's faster than that, you now begin to lose soil strength. You're already digging the soil. You are weakening the soil. Though, normally, if it's a long project, if you wait, if it's a project that you need up to 1 month or 2 months or several months before you go and complete the project, no problem. The soil will come back to its position. Okay? But if it's a project that as you are doing, you are finishing, you have to keep to that. And then revolution is kept between 10 and 40 revolution per minute. How many times do you turn around in a minute? Between 10 and 40 maximum. Some people will say 25. If you keep to that one, you will maintain that penetration. All right, which is what everybody is waiting for. She's don't enter fan. What are the possible problems that can challenge, that can happen on site? Product problem. That is from everything you buy. Problems associated with it. Of course, misalignment. You are not able to plumb. You are doing whatever you like. No quality control, no check, no surveyor, no templates. You just do what you want. You misalign. And when you misalign, you are now introducing excessive stress. So it can cause the shaft to break. Even though the torque indicator will help you. Again, you forget the torque, or you say, I don't sabi am. Me, I don't put torque indicator. Believe you me, most of these Oyinbo people, they don't even use it. Number one, it's expensive, and they find out it's not necessary. They have idea of what it is. They use pressure in the machine. Some of them have calibrated it with the pressure showing on the excavator machine. So you don't need this one. You can save some money. But even at that, they are still recording the torque. So based on that one, you miss it. Maybe you're on the phone. You get your anything can get damaged. Let me just not say the shaft. Anything, the coupling, the bolt, anything can break. And so what is the solution to that? What is the solution to that problem? Make sure you align. Proper alignment. Control measure. Axial means directly on top of it, or any direction you're supposed to go. Nobody say you go bend it for 30 degrees. Excavator going to 25. Yeah, eccentricity. It can damage, it can fail completely. But then, if you are sure everything is correct, your angle is correct, you have a video, you have evidence you are proving it, you have the torque machine measuring correctly, is everything okay, and yet your shafts or anything fail, money don't come now. You call the manufacturer, you be like, say, we don't understand. And if they are sure, they trusted you, that's why you have to be their certified installer. They will not doubt you. You buy everything from them, use their torque wrench. All this way they will carry you go cut. You do and tight. They say, bro, no verse. We'll go arrange come. That's the first thing among so many things. You don't expect this course to take everything, but we'll try as much as possible to take what is possible or what we can remember. Like we said, the bolt or the coupler can break. So that's a fastener. Fastener means attachment. Either bolt or pin or welding. So the bolt grade is correct. If the pin size is correct, sometimes they give you buy 2 different type of helical, what do you call it, parts. And the pin, yes, they are, maybe one collect 12 mm, one collect 16 mm. As you know, 16 mm, you carry 12, you put there. Just because you don't want to go back to the store. Or they say, maybe you put 3. You say 3 go carry, 2 go carry them. So that I can have enough to sell for Bola. You know, those operators are funny. Bola is very, very important now. We have to consider them even in 2 bus stock. If you are working in a size that is not controlled like LNG, it is important. Because you go overnight, before you come tomorrow, they turn blue to white. And they have incentive for workers. You know, boat is very small. They tip them, they have all of that. Workers can be tempted, and they say, this thing, 4 boats, okay. They put 2 today, walk. They put 2 first. All those extra, they are targeting it to arrange. And then Kasala burst. It don't happen. They forgot that maybe the talk you saw yesterday will not be the talk you install tomorrow. So all of that is also important. In fact, we should add that one as a problem. Bola. Abi? Incentive for stealing. What is the solution? Control measure. Don't employ thief. Pay well. Pay well. Don't employ thief. Adequate security. Supervision. And you always take inventory. Whoever sign them, now you enter them. I didn't say you should write that one down. This is the talk motto. This is the driver of the pie. It turns, it drives. You can overuse it. When it's not aligned to, seal, feel burst. The seal is on the neck. That white shaft you see there, that's a mechanical seal there. If it bursts, gear oil go leak. And all of that. Maybe when you finish work too, you drop them for sand. You understand what I'm trying to say? Operator, they very careless. You put them for sand. Or we are working in salt water. You decided, you forgot that you have it attached to your excavator. You wanted to carry, somebody bring fresh fish from the other side of water. Okay? And you put it, say, yeah, hang them there. You turn it to a lifting equipment. You enter salt water. You don't know, or you don't care, either of the two. Before you know it, it's still okay, it's supposed to work very well. You damage it yourself. Things happen, and all kind of things can happen. Or they gave me money to go and buy a TA16 as you are seeing there, and I look at the price. I think, nah, man, I got me don't know anything about this one now. Make I buy TA8. Abi? Lower capacity. You know, you go cheap now. What are you talking? You know how many dollars will enter my pocket? Or instead of going to the manufacturer, I go the other side. I don't want to mention place. Or you buy second new. Yes, for my 3. Or Ayama. All of that, you have an incomplete or low capacity or inferior quality. At the end of the day, since you know you won't cover yourself up, talk is supposed to be what? You don't reach. You know? Or you say you don't reach, refuser. Everybody believe you. Then you have created a bad pie with low capacity. The pile is incomplete and all of that. What's the solution to all of that? Use the proper drive tools. Make sure they are in good condition. I didn't have this one. Use it for what they are meant for. Don't turn it to a lifting device. You can be tempted sometimes. You know, as we are walking across the fence and our pile is here and we need more pile. Instead of to say we want to wait for a crane or something to come and go behind. Say, yeah, tie him, hook him. But now, your buy them now, never use them more than 2 days. You now begin to threaten the manufacturer. Inside you know you are the one that damaged it. So all of that, solution is If it is actually due to the manufacturer, you call for replacement. Maintain preventive maintenance, ABI, operator specification, whatever they recommend by a manufacturer, you keep to it. Make sure your torque indicator is not kept in water. Rain the fall, you leave them there. So you know what, because it's very heavy, actually it's very, very heavy. And you're walking far away from your store. So to carry it, say, cover them with nylon. Cover them with nylon or proof. You didn't put something under it. Everything inside. Did you cover anything? So you also protect your torque indicator, whatever you are using to work. What was mentioned that time? That could be a problem. If everything okay, you break. We have said it now. When the thing break inside ground, if you call for the man or the contractor or the supplier, they make you one. But then the one with the inside ground, what you want to do to them? And you can't use that space again. You change location, but you will not just decide. It has to be in collaboration with the engineer, or whoever is a little bit above you, who can make that technical call. However, I mean, in general term, if you have a dimensional deviation is allowed. To the right, I think is, I can't remember now, depends on the code, maybe 150 to the left and all of that. But if you can do something that will make it stronger, for example, you are supposed to have a 3 meters interval, and that's a problem. You now begin to have 2.5 meter interval. You have added to the strength of you have not done anything wrong. As far as 3D is maintained, sometimes they allow 2.5D for this situation, and they can see overlook. For example, the more you bend your angle, the better the resistance. So if the contrast says 20 degree, and you're on 20 degree, it broke, you can't retrieve it, everywhere blocked, or there's an obstruction like a stone, like you said, it didn't go. If there's nobody who can make quick decision, though you will record it, you can turn it to 25 degree. 5 degree from the beginning, it will be almost 3 meters at 70 meters. It's like a, you understand what I'm trying to say? Do you understand that? You don't understand, I'm sure. Madam, you understand? Okay. Somebody want to help her? Okay. This is our design anchor is 20 degree. This way, 3 helix. This one gets here and it broke. Technically, you can go like this. 5 degree from here. You can see that the more I'm going, the wider it's becoming. By the time you get here, maybe the thing broke here. Look at the gap here. You have dodged whatever is obstruction there and go. And you can also probe. You probe with a tiny, you can probe with a tiny or smaller single auger, single helix. So if it is 8 inches, 10 inches, so you can just use 8 inches to go through. You can always receive it. Then you come back again and put the right one to confirm that you have dodged. So if you happen around here, you put a smaller screw and go this way. Immediately it goes to the, okay, don't pass out. You come again. You don't need to get to where you have it. And then you add it and continue. Does that make sense? The higher the angle, that's the truth. It's better. If it is increasing it here. If you are going this way, you are creating problem. And that's why I said at that call, you don't just make it the way you like. Because before you know it, okay, no go. We don't change them. Because at that point, you will need a shorter length. And again, if Bola is very, very important in that area, there will be a lot of off-court for boys to. So all the extra. No. Madam said, go. All right, that is that. For the tooling or equipment problem, I think we still have. Yeah, you have rock. According to this man, we have rock. See, I'm there. You come back with your auger, you never damage, you straighten it. You carry ham and knock ham. You carry gas, heat ham a little bit. To straighten it, you can reuse that one. If it is 8 inches cut, it's spoil. You cut it off. Instead of having 8, 10, 12, you can have, since you have cut 8 off, you can put 10, 12, 12, or 10, 10, 12. It's the same, you have Espra, you have spear. Yeah, it will not damage. Do you know the temperature they use to apply the galvanization? It's not a small temperature. So, metallurgy people will tell you that. That gas fire not be anything. All right, you can have that, and that is the solution. First, you have to retrieve your auger, reuse if possible, or replace. In replacing, if you are able to get them out, fine. You can follow the same angle. If it's not an obstruction, maybe it's a force or something or negligence. But if it's an obstruction, you can remove, you dig, remove the obstruction, and continue your work. If you cannot remove, you move away. At that time, you need a third party or higher authority approval to do that. Anything else? Again, installation issue. The first thing you must have is what? Competent and trained staff. Not just anybody. I don't do it for America. I don't do it for London. Show us. So whoever is doing the job must be competent. And like I said, those people who call the competent people or the certified installer, they don't have to be the one operating the machine. They don't even have to be the one putting the pin. You know what? You can see those ones there. This one's a fine boy supervisor. But they are the one who can say things are okay. And the manufacturer also beat their chest that this man, because if you go and tell the man, say your thing, they say, who install them? It's not a certified installer. Sorry. Oyo. And this certification we are talking about, there is no standard general certification body. Every manufacturer certifies their own user. You are buying from Chance. It's Chance certification you will get. If you are buying from Piatech, that's another one. That's the certification they will give you. You have Piatech, yes, you can use Chance equipment, but when it comes to this legal matter, it's spoil and no spoil. They will tell you, okay, we don't know this one, we install them more. So we cannot guarantee that it did it right. They will not even sell for you, that's good. Because they know you come back with a court case. So if you don't know you, so you can buy, but they will ask you how to install. They will tell you, well, we will recommend you let's train your people. That's why we are here. Let's train, or somebody who have trained can train them. Okay, and then after you do some installation, it's the same certificate I guess you will go and get. It's like WAEC. When you don't go lesson, tire, you don't do everything, pass question, everything. You not go and. You can't have certification in 1 day class. You can have for design. That one is simple. If you are seeking certification for design, there's certification for design. There's certification for installer. There's even certification for installer of tie back, which is what we are doing now. It's even from the one installing for building. So there's certification for every other stage. So, of course, this is how you start. You attend seminar, you attend workshop, you work on yourself, you pray, you go and do some, if you have small money, you wear this small thing in your house, you do it yourself, you try and learn from it. Anywhere you see they are doing it, you pay attention, and all of that. You cannot say, yeah, I'm good, or yeah, I'm all right. And as Evomec now, being a customer for chance, when you are ready, we will enroll you. I don't know whether you understand that, as an installer. And then you repeat this course online. Or if you are lucky, you fly. You go abroad, go to the office. Bring them to Nigeria, they say they know they come. Do you understand it? So it is important you have competent staff. And now you become trained staff. We can all do it together. On site. Okay. Like, look at that setup. The excavator is putting vertical pressure on top of it. Abi? And it's also rotating it. If the pressure is not enough, or is too much, they can create a fake impression that you have lack of capacity, because everything you do is soft. When they say rotate 25 times in 1 minute, you are rotating 100 times. If people say you don't get capacity, everything goes pia, 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 I don't finish. You go say, this is soft too. So you may have lost capacity by disturbing the soil. Instead of putting the thing inside, you are removing the soil. And you can also damage your equipment. You can damage hose. You can damage a lot of things. So the solution to that, what's the control measure? You apply the right pressure, control the RPM, maintain the penetration rate, put your eye on the ball, and make sure your equipment are also very, very sound. You go and bring them where they do a session for site. Okay. That's problem that can come out that's related to installation. It's more or less going around the same thing. If you are not competent, of course, you won't know the pressure to put. You won't know how much penetration you need to do. You don't even know how to do the alignment. You don't know how to check the angle. You know nothing. Then you are a quack. My people call you a Congo. All right, after you have done all those things you think you have done, okay, let us test them now. Let's test. Somehow maybe you have overstressed the item, or somehow you have broken small welding due to overuse, overinstalling, wrong installation. Your plate you don't cut inside ground, you don't know. But you install. You have 3 plates, 1 don't cut. Okay? What will happen? You test it. By the time you are testing it, instead of the pipe to fail, you just find out say, the rod don't come out. The other one is inside ground. Something has broken. So that also happened. The pipe is not able to perform, even though everything look okay to you. But in the real sense, nothing is okay. But at least you are able to drive it. And it look okay. Or actually, nothing happened in terms of, it's just that you design, maybe the soil information is wrong. You design for 70 ton, you are now getting 20 ton. Of course. Maybe you took too much time, 1 rod loss, you go and buy for my 3, you weld it, you paint it ash color, instead of galvanizing. And somehow you have a corrosion. By the time you test, it fails. Or when you are applying too much pressure, the rod don't bend. All of that come up to performance. You have done everything, but now the job, the man cannot do his job that you employ him to do. The pipe can no more support what you plan it to support. He couldn't do what it's meant to do. So, first, check solution, check your detailed design. Is it correct? Where did I buy the materials from? Is it from a reputable manufacturer? Then you do tests again, make sure everything is okay. Then you are likely going to, at the same time, have competent people. Do what you need to do. Keep your machine very well. You have dealt with every possible constraint or challenge that can come up. At least that we can remember this afternoon. If you want to help me out with any other one.
The rotary machine, that is the pile driver. Yes, any of the three names, okay. It has a reverse.
Yes. You have to reverse to be able to pull. You are turning, it depends. Some manufacturer, they turn left. It depends on how they bend look at this one. This one, the step down. Okay, let me use this one. The step down is to the left, Abi? Or to where?
The step down is clockwise.
Okay, so this can go clockwise. Some, they produce it, you have to go anti-clockwise. So if you have to retrieve them, you go opposite what is meant and you lift. You lift just the same penetration as you are turning, 1 revolution 3 inches, 1 revolution 3 inches, and you come out, and you are out. Some can go both directions. Some you need a device. You understand? But they deliberately make them to go one direction at a time. If you want to reverse it, you need to change the hose. Because some people will forget. Operators sometimes, you know how operators say, move, go front. Instead of going front, they go back first. They say they never put their attention. You have not seen it before. Even crane operator, they will not move. They will just shake. The first, they don't know where to go, so they want to test. Huh? No, that is not gear. This is common with crane and excavator operator and collar operator. You have them, you come front. They don't know where they are. So the first test deliver. You go and go back. Oh, okay. So no way for the machine, you cannot go the other way. So if you need to go the other way, you have to change the hose. Or you go and have additional control lever that is bi-directional. It's deliberate and intentional. Mm-hmm.
Like maybe if we encounter some of these, any of these challenges, then when we retrieve the pile, is it still advisable to install it on the same area or you move to another area?
Like it depends. Problem can be a block, they go. You probe, confirm there is no obstruction like a boulder or pipe on the buried structure like pipeline nobody know, or old pipeline that everybody has forgotten. It is foolish to go back again without probing what happened. So, like you said, if it is far away, that it is more expensive to probe, and it becomes cheaper for you to introduce 2 additional helical pipe. You could do that one now. Take another direction. Okay? But if it's something you can probe, you probe and you see that it's not something big, you remove it. If your hand can reach it, then you continue. Any other one? Any other one? 20 times they talk. 3:37. We're moving too fast. We want to take some work. I see some people are closing eyes. Let's do 5 minutes work and everything remaining is all video. Go and pee. My daughter had to talk to like that before she sleeps. Go and pee. So this session, we play some videos. We all see all what we have been talking about. Different type, slightly different. We'll do for vertical drill, we'll do for tie back. And then we all see summary. These are, again, we're able to play this one because these are all the same agency, chance group, so we have right to play them. So we are not copyrighting. Okay.
The installation tool, which is attached to the drive head, is placed onto the square
What is
shaft.
that mark?
Plumbness is
That
checked
is
in
survey
two
peg.
directions, and the lead section is
The
then
surveyor has put that
advanced
point.
into the ground until the top helix is approximately at ground level. The extensions supplied by Chance are all stamped with quality assurance numbers. These numbers indicate the material, the year, the steel supplier, and the heat number, and are used to trace materials through the manufacturing process and into the field. Before being installed into the ground, extensions are marked in 300 millimeter, 1 foot increments to allow for easier monitoring of torque, as torque values are to be recorded at 300 millimeter or 1 foot intervals during installation. The first extension is placed on the lead section and mechanically connected with a bolt. The bolt is tightened and a lead displacement cone is pinned into place approximately 450 millimeters, 18 inches above.
I've seen that in what we've been talking about. This is an helical pie that is planned to be grouted. They want to grout. And that lead cone that they are putting on the shafts will keep the hole standing. So around the shafts, the hole will have some alu around the shaft so that you can pour your grout. Our work does not require that. So that is, like I said, all these accessories depend on the intention or the use of the helix or helical pie.
The top helix. The displacement cone creates a void around the helical pier shaft as it advances into the ground. Grout is then poured into this void, creating a consistent grout column around the shaft of the helical pier. Once again, the installation motor is mounted onto the shaft of the pier, and the pier is advanced further. Once the first extension begins to enter the ground, the monitoring and recording of torque values begin. The displacement disc enters the ground, creating the void around the shaft. The void is now filled with grout. The level of the grout is maintained as the pier advances to ensure gravity forces the grout down the void. This creates a consistent grout column around the helical pier shaft. The grout level is continuously topped up. Each additional extension is placed onto the shaft of the pier and bolted into place. A centralizer disc is placed onto the extension to keep the shaft of the pier in the center of the grout column as the pier advances. Also, it is used to keep the grout column open to allow for better flow of grout. Once again, the level of grout is maintained. The installation torque is monitored by using a differential pressure gauge. The pressure reading from the DP1 is correlated using a calibration chart and provides the torque applied to the pier measured in kilonewton meters or foot-pounds. As the pier advances, the level of grout drops as it is pulled deeper into the ground. As torque on the shaft increases, the shaft will begin to twist.
Here to explain, if we have intention to use an hydraulic gauge to measure our torque, we are going to be measuring pressure on site. Okay? How do you know the torque value? In the morning presentation, I gave a formula for that. So, you as a supervisor or with collaboration with your engineer, you will have done it in the lab First, we will have calibrated the pressure with torque. So we'll put the torque machine there, and then you calibrate for different values. So you can say 100 bar equals to so-so cut torque value. 200 equals to torque value. And as design, as this job is designed, you know the torque you are looking for. So you must have determined the pressure equivalent in the office, not on site. So by the time you are giving instruction to your site man or the rigger or the installer, when you get to this pressure, don't go again. You understand that? So, just to chip in that, let's go. Yeah, I've told you it's not part of the work. So stop.
This twist is an indication that the pier is beginning to reach its maximum torque limit. It is designed to do this. Torque is applied to the pier until it reaches the maximum design torque capacity as determined by the manufacturer. The torque readings are recorded, and once the installation is complete, they provide a summary of the installation of that pier. The top of the pier shaft is cut flat at the appropriate elevation for the test bracket to be placed. The test bracket must bear directly on the solid steel square shaft. The plate is leveled to ensure safe and accurate testing. Next, the reaction anchors need to be laid out. The reaction anchors resist the vertical loads created when the compression test is being completed on the test pier. The size and configuration of the reaction beams are taken into consideration during this step. The location of the reaction anchors are measured and marked on the ground. The anchors will then be installed, followed by the beams, so the compression test can take place. A tension anchor is now being installed. The tension test installation begins in a very similar fashion to the compression test installation. In this demonstration, the tension anchor being installed will also be used as one of the reaction anchors for the compression test. A tension anchor is installed in a very similar fashion to the compression test pier. The first extension is installed and bolted into place. In this demonstration, the test anchor will be installed without using any grout. Again, the torque is recorded and plumbness is checked in two directions. A threaded adapter is bolted to the top of the anchor so the test beam can be attached to the test anchor. A tension test will be demonstrated first. Some wood cribbing is put in place, and the beam is placed on the cribbing. The load cylinder is placed on top of the beam. A threaded rod is attached into the adapter previously connected to the test anchor. The nut is tightened on top of the test plate, which holds the test cylinder in place. Using a tripod, the deflection monitoring equipment is placed. The dial gauges in this case have a 50 mm, 2-inch stroke. 3 dial gauges are set up to monitor the average deflection. The cylinder is used to apply the load to the test anchor. Deflection or movement of the pier is monitored and recorded at specific time intervals as determined by the test protocol. Deflections are documented on the test recording sheet. At each load increment, the load is maintained by using the hydraulic jack. Once the test is complete, the load is released from the anchor and final readings are taken. The testing done here generally conforms to the ASTM standard. The amount of deflection can be seen by observing the gap in the plate as the load is removed completely. This is the beginning of a compression test demonstration. After the reaction anchors and the test beam are secured in place, the cylinder is positioned between the underside of the test beam and the...
All of these are just to verify now. The first test they did was for tension. This one is for compression. you will appreciate it more when we get to site. Exactly what you see there, we'll do it on site. Okay? So we'll try and do it, and you understand how it works. We may not run a full scale. We're going to do a quick test, but we'll do this setup. So we'll do all of that on site. We'll take measurements. That's what we want to use tomorrow to do. Otherwise, we won't have space. So tomorrow we'll do all those small setup on site, so that on Monday we just go straight to the operation. Yeah, you consider everything. You have to determine, because the unload will determine whether it has getting to permanent position. And that's another unloading. If the thing reduces when you unload, you can also confirm the elastic extension we are talking about. What do you want to say? Practicalize it by talking it.
Okay, I want to know how they got that
Beam.
Like two tapes crossing each other, trying to get the center. I don't know whether they got
The red paint.
No, I saw where they took a particular measurement from. I don't know if it's from the.
They are trying to set up the reaction system. You also centralize, making sure that it is at 90 to get exactly centralized load.
The top of the test pier. The jack is used to start loading the test pier. It's important to make sure there is good contact between the hydraulic cylinder and the test beam. A small preload is typically placed on the test pier to ensure the apparatus is safely secured into place before carrying out the test. Deflection monitoring equipment, similar to that used in the tension test, is set into place around the test pier. The hydraulic jack is then used to apply the load to the pier. The dial gauge moves as the load is applied. All deflections are recorded on a test sheet. Deflections are measured at the beginning and the end of each load increment. During each load increment, it is important to ensure the load is held at the required load interval. After reaching the maximum applied load, it is released in increments. Measurements are taken, and results are recorded on the load test sheet. Testing generally conforms to the ASTM standard for compression tests.
Chance helical piles can be installed with relatively small equipment. Typical installation equipment is a hydraulic drive head mounted on a skid steer loader, excavator, or backhoe. Helical piles are relatively quick to install and require little or no ground preparation. The excavator operator crowds or applies downward pressure during the installation of the lead section at the beginning to minimize the amount of disturbed earth at the top of the hole. The groundman must assist the operator in keeping the installation plumb. This is very important when installing the lead section in the first plane extension. The operator should be able to see the pile and keep it plumb to his left or right direction, but will need assistance in the front and back direction. After installation of the lead section, a plane extension is added to extend the pile to the appropriate depth. Extensions with additional helical plates are also available if needed and help in generating more torque, which means more load capacity. The connection between pieces is a forged male-female connection with a single through bolt. A 12-inch or larger crescent wrench is used to tighten the bolts. Connections should be double-checked to ensure that they are positively connected. After the connection is checked, the installation continues. Accurately measuring the installation torque is the single most important item that the installing contractor is responsible for. The installation torque has a direct relationship to the load capacity of the pile or anchor, much like the driving force is related to the capacity of a driven pile. The device being used here is a mechanical dial torque indicator. It is inserted into the tool string and directly measures torque. It is very accurate, but it is expensive and is not very production friendly. The most production-friendly and economic method of measuring torque is to insert a hydraulic pressure gauge in line with the high-pressure hose supplying the drive head with hydraulic power. The drive head requires a certain amount of hydraulic pressure in order to output a certain amount of torque. Because different pieces of equipment that may be used to operate the drive head will have different hydraulic characteristics, such as back pressure, the same drive head will behave differently when used on different pieces of equipment. The drive head should be calibrated to the piece of equipment with an inline torque measuring device, such as the mechanical dial torque indicator or the shear pin torque limiter, which will be demonstrated later. After several piles have been installed and the pressures recorded with the corresponding torque outputs, a chart or a curve can be plotted. Then the inline torque measuring device can be removed and the readings can be obtained from the hydraulic pressure. Notice the speed of installation. Helical piles should be installed at operating speeds between 8 and 16 revolutions per minute.
The installation tool, which is attached to the drive head, is placed onto the square sheet.
This animation is what the project is all about. A tie back. You can see the wall, is it not? You can see the anchor there. So let's do it. as the what? What that go directly under the, on top of the adapter. This two layer. In this case, one layer is not enough to sustain the wall. They're making it 2 layer. It's all design. I think we should be done with this one, basically. This is chance.
Chance helical tieback anchors provide lateral support for many retaining wall applications. A helical tieback anchor is installed by rotating or screwing it into the ground. Each helical bearing plate is formed into a screw thread with a uniform defined pitch, ensuring minimal soil disturbance. Here, Chance helical tieback anchors are being used to add additional lateral capacity to a sheet pile retaining wall, stabilizing the bank on the edge of a lake in a residential application. Structural retaining walls use soldier piles with wood lagging, sheet piles, or structural diaphragm walls to resist lateral earth pressures from retained soil. Chance helical tieback anchors are engineered steel anchor elements consisting of a central steel shaft and one or more helical-shaped bearing plates. Tieback anchors are installed until the helical plates are located well beyond the wall face deep into load-bearing soil and then attached to the retaining wall via a thread bar, bearing plate, and nut. Engineers can design a tieback anchor configuration by inputting site soil data into Helicap version 3.0 helical capacity design software and validate the design using torque values recorded during the installation, resulting in a proven engineered system with predictable and verified capacity. Applications for Chance helical tieback anchors include permanent and temporary sheet pile walls, bulkheads for marine applications, concrete reinforced walls, and precast concrete panel walls. Helical tiebacks can be used both to remediate falling walls and reinforce new walls. To learn more, visit chancefoundationsolutions.com or call 855-477-2121 to find your local.
Remember that when we traded bullet, he said, yeah, we call that job in the anchor. And I said, why do you call it that? He says, this guy didn't do it. He got about 20 feet back and broke off.
That joker's driving good.
Not only is it open, it's touching the side of the pipe.
Yep.
So no worries.
I
bet you can.
Here we go. Hold my beer.
Hey, wait a minute.
These would be good for securing park benches, getting stolen and things, small little stuff like that.
But see, that could happen. You do a municipal seawall. That could happen. Low drop, things like that. We did it like this to open it up. Now we got a good little anchor that goes down here. When we put that tin up, we can have tie down. Yeah, it's like 1,400. 1,400? Yeah, 1,400 foot. 1.4 kip feet. See how we're advancing at 3 inches per revolution? That's critical. For tiebacks especially, it's critical that you get your 3 inches per revolution. Get the other stick. That's where the stick is at. You're out in the field, it's your job to help them perform. Grade 2, when I say this is a 40 kip manta ray, people will tell you it's a 40 kip manta ray. Mechanically, these for a demo every time and couldn't get them. After a little while, it's supposed to look like a 1400. Right, but we're going to see if it works. Now see, it's going real easy. That wasn't it opening up. That was, huh?
Trying to do like a foot up.
Little twist. Clockwise. Another light right there. I guess clockwise is not really good. Like this. I know. He's proud of himself. Force. And it's a sticker. It's a blasted sticker. I don't like to leave that hole. Drop the bolt or something. Things go down there and they never come back. Of the test, he'll look and say, "Oh, that thing's still. Go to the next one. Go." And because
Sometimes some stuff can get in those threads. Make sure you get it
this way, because this turns this way.
Very good point, too. This is
that's one of the things you do. Y'all can see. If you pull it out, you get to be king. Look at him! Ah! This is a rental now. It don't need the tags anymore. That was what? $15? $13. Not a bad thing. All right. This one countersunk farther than we would have liked. That ain't all bad. Now, you can see that that thing is getting open. All right, so I was driving. Where was the anchor?
The tieback process begins by driving the sheet piling. The piles are vibrated into the ground using a hydraulic hammer. After the sheet piles are installed, the soil can be excavated. Next, the PureTech helical tiebacks are turned into the soil. The torque is carefully monitored throughout the entire installation procedure. Once the tiebacks are installed, the threaded adapters are bolted into position. Then, the I-beam whalers are installed over the threaded adapters and bolted in place. When construction is complete, the PureTech helical tiebacks can be removed and reused on the next project.
A lot to show. There is a lot to show actually, but it is not as good as doing it yourself. So all we need to prepare for is to get it done ourselves. Now all those talking video will come to light. By the time we come on Monday, we pray the weather, we have good weather, so that the rain does not disturb us. So in all, what are the takeaways from this installation? Can somebody suggest?
Okay. Good evening, House. So far from the video of this very session, a brief takeaway that I observe is that first and foremost, before we start installation, we must have technical and competent personnel on site, proper supervision. Also, we have to use the right equipment for installation. And also, supervisors should pay attention to monitoring the entire process so that we don't end up either wasting material or damaging the helical tie rods and all that. That's the little I can contribute here.
Any other person? May I begin point hand now? May I call name? Somebody's already afraid I'll call you. Bros.
Okay. I took down the quality checks, also the revolution per minute. Safety also spoke about the right personnel for the job. Then safety, although safety was not included in the videos, but safety should also be priority. Then use the appropriate instruments, the torque indicators. Do not neglect any parts of any instruction or any protocol. I think that's...
Okay. For the installation of these anchor piles or helical anchor, we need to be very, very careful because number one, the materials they are not materials that you can easily get in the market. So during the installation, we need to be very careful and pay attention to all the process so that number one, we don't get the materials damaged, so that to avoid the rework or to pull out the material to reinstall. So in order to achieve that, all the connections, the bolting and unbolting, we must make sure that we get it right. During the driving in as well, we maintain the required speed. We don't overspeed and we don't underspeed. I think.
Next person, no?
Good evening. Good evening. I noticed there was teamwork from all parties because I noticed there is a place where the survey man actually. Yes, I am. So the survey man actually pinpointed some places where it was pegged. Yes, so if there was no teamwork, maybe the engineer would be arguing with the survey man and all that. So that's what I observed.
Good day, sir. Basically, one of the reasons why we're here is for us to be trained, for us to know what we're going to meet on site. So one of the take back I understood was you must use competent people, personnel for the job, and then you ensure that the right manufacturers, certified manufacturers are those you go to when you want to buy your materials for the same job. And then we must ensure that the talk reading is being taken into consideration. We must also ensure that talk reading should be taken. That is one. And then the angle of inclination. And then going forward, we should just ensure that we understand the job or task we are being asked to do. So that's the little for now. I know I can take back home.
Good evening, everybody. You stressed on competent and trained personnel must do the job, and we should maintain the pressure being used or stipulated for the design. Then we should ensure double checks in order to avoid errors. And then you said we should take step-by-step procedures. We shouldn't miss anyone in order for the job to be done properly.
What's it called again? Sorry. No. One key takeaway I got was that our helicopters must be properly galvanized.
Okay. This is a very interesting training, and one of the key takeaways here is that the talk is very, very important. And before we go for installation, we have to make sure that the talk rating is from a licensed manufacturer so that we wouldn't stand the risk of failure. Also, another takeaway I was able to get is that if the penetration is less than 80% of the depth, we can recheck and find out what could be the problem. And finally, we should always monitor the talk so that we'll be able to get or to determine the points of refusal if it is in line with what was designed. Thank you.
Planning is one major part of the whole process, because if we don't plan all of this adequately, there'll be a lot of unexpected occurrences. And competency gap is one of these, is another factor we are trying to bridge. So, and that's another takeaway. A talk monitoring device is crucial to the operation to work all of this effectively. The revolution per minute, just to keep all of these checks to aid the installation process. I know safety is not really emphasized on all of the videos we've watched. We consider safety too in all of this. The angle of inclination, the installation angle, and the orientation during installation is important and crucial to the operation.
Two people actually mentioned what I wanted to say. But just to add, I think one key takeaway in all of these things we have learned so far is that this job, is not, you could see all the videos we watched. We didn't see any video that people were crowded. So it's a specialized job, not for some my 3 persons. Perhaps that's the reason why they brought us out from many to train us ahead of the time for this training. So to say, it's also not a job that you will calculate in mind, maybe at home in your mind, that today we must make sure we do 10 piles or 5 piles. You could see that everything has processes. As you're piling, you're calculating the pressure, the torque. If it is, in fact, everything depends on what happens around the environment there. It's not something you will stay at home and plan coming. So it's that kind of job. So in all, it's a specialized job. So we have to do it one after the other, according to the steps given to us as well. Thank you.
For me, one of the key takeaways, just to add to most of what have been said, is from the way the installation training has been presented, we can see that it is highly procedural in terms of the sequence that was, outlined. And one of the things that comes with jobs that are procedural is that over time, there's a tendency to find, shortcuts, violations, which is a deviation from the procedure, and which could lead to accidents, could lead to errors, could lead to poor quality of the job and the like. So it's very important that, we put measures in place. For me, one of the key takeaways, putting measures in place to ensure that no matter how many piles we have to drive, measures are put in place to ensure that the procedure is not deviated from. Even though it means having to, rotate people, maybe from a little bit of time to go and rest, to put another person, any measure that can be put in place just to ensure that the procedure is adhered to and prevent violations. Thank you very much.
What was online? Okay, so guys online, can you hear me? Inzube Adoga.
Yes, we can hear you. Go ahead.
All right.
Invite your parents to come and discuss why.
Inzube, can you please give us a keynote, a takeaway? What, at least you have been online, what you have achieved from this little training? If you can, also you can enable your video so that we can see you, you see us too. I think it will help us better. Before Adoga, Inzube, we'll start with you. Thank you.
Okay. Good evening, all. Thanks for the section. I think it was quite an interesting one. I appreciated the way the coordinator used visual effects. So those ones struck to heart. At least you can see what what we are talking about. If you have a construction experience and you have piling experience, you will see that those actually give us a good practical example. Though I didn't join from the beginning, the sections I listened to, it's something that I will encourage, especially for the Evomec team, and to really guide them, especially for this project, the shoreline area. So I appreciate what you're doing here. And, of course, Ferdinand, you know that this is quite timely for our work. Yeah. Thank you. Over to you, man.
All right, thank you, Inzube. Thank you for staying back with us. Adoga, are you there? Is Adoga there? Can unmute and give us a keynote takeaway. Adoga is paused. All right, so we have heard from our guys online. At least Inzube is is cost control focal. So on this project, so this is part of what we have planned to do to train guys in the job and outside the job for as professionals for future purpose. So Alaji, any other, where are we now?
Yeah, we're just starting. We are not ending. This is where we share the money. Look at the screen. Go ahead.
Sir, there is something I want to ask. So, sir, please, your pen. From what you drew here, I said this is the pile. And then water level. Let's say this is the first one. Sorry. Okay. And then you said it was in an angle of 20 degrees. And then if in the course of piling, if in the course of piling, we get an obstruction or we meet a barrier, that we can come down further to 25 degrees. For example, now, let's say from the video I saw, I understood that those piles they have a particular level. So what if the next one, it's here, another one, it's here, and we're giving an angle of 20 degrees for all, 20 degrees. And these ones are going down. And then here, we met an obstruction. After you have rectified this, let's say, for example, for it to go further, will you continue with this 25 degrees or you have to go back to 20 degrees? And then the question now, another question now, it's what will cause reduction in the installation rate?
Okay, I start with the last question. What could cause reduction or slow penetration of the helical pile? Can anybody answer that? With the training you have done. Say that again. Nature of the soil. What else? Poor pressure. Wrong information. Obstructions. You already answered it. You already know the answer now that you have asked the question. So there are so many things that can cause slow penetration. Bad equipment. Okay. Bad alignment. You think you are doing 20 degree. Maybe you are in 15 degree. So many things can cause that. So I'm glad everybody is able to do that. So here, the challenge you assume you have, probably you don't know, is that you are looking at different view, or should I keep it on your page? This is a slice, a section across the pie. This is just a section across the site. Okay, good. This is good. This, let's say this is, can't move, okay. This is the water side of our helical pie. This serves as our pie up to this place. Behind here is where our equipment is, the ground, inside the LNG. Are you with me? You are installing like this. Do you have something longer than this? Do you have something like a ruler or something? Quick. No, I want something that is slender and long. Okay, pen, we can manage. Okay, let me use this mic. So, this is our, can your camera go up a little bit so that it doesn't see the, yeah. This is our helical pie at this angle. Let's say this is 20 degrees. I said if you have obstruction and it's not going, you could reduce the angle this way to dodge that obstruction. I didn't say you should go like this. Do you understand the difference now? The angle we are talking about is vertical inclination. That is to the face of the wall. The next helical pie, as per design, is here. So it has nothing to do with the one here. This our job does not require 2 layers of helical control. One here, one here. So if it's what you are afraid of, if it's here, you are believing that if we come here, we'll hit this one. Immediately we have a change of angle here. Of course, we will implement the same angle here, so that the two will become parallel. Does it make sense now? Does that clear your question? Thank you. Thank God we are here. So you must be able to visualize your drawing, 2D drawing, in form of 3D. And that's where you missed it, yeah. Or you helped us understand it more. I think that's better. A lot of people may have the same thing, that they are not able to say it out. All right. The next person. Who want to ask for my name?
Just for more clarification. You talked about 80% and 85%. Shouldn't that be applied to the torsional resistance instead of the depth?
What is asking me is that I said if you are able to attain 80-85% of the design length of any pie at all, it is assumed in measurement that we have done the job. So it is not already, the manufacturers are not giving you the torque that will damage their shafts. They are giving you, they have also applied safety factor for that. That's on one side. But that has nothing to do with length of pie. If somebody gives you a job for 10 meter or 100 meter pie, normally according to FIDIC, you have to do what you are paid. If you are, sorry, you have to be paid exactly what you have done. It doesn't matter. There's some other contract too anyway. It depends on the contract term. Let me not even say FIDIC. So if you do 80 meter, they will pay you 80 meters. So there have been various court cases, all kind of situation. But then we now look at safety factor and all of that. That 20% difference, you have a safety factor of 100%. Is it not? 2. You have a safety factor of 100%. So 20% has not damaged anything. That is, if at all, we call it diffuser and the resistance is not enough as you thought, because the capacity is a function of depth. So when you are within that same range and in the same soil, the capacity won't be much different. You remember, capacity is a function of the area of the pie. So generally speaking, for helical pie, this is what matters. You are supposed to put 5, you put 5. You put 3. The length here is not a function of, it's a great function of capacity if you are to be normal pie. But in helical pie, it doesn't really make any difference. You have driven your excavator to the normal power. You have used your torque meter to the normal torque that you have been paid for. Whether you get it here, you get it here. But what they will tell you, when it is here, the reason why there will be a pause to pay for the measured work could be for the fact that you may not have achieved the aim of the project. It's not because they don't like to pay you. The man does also not to, he doesn't want to pay for nothing. The men paying you also want to be sure that even if you are using 2 meters here, you are not deliberately trying to cut corner. You understand? Because somebody, if that is the case, instead of doing 30 meters, let me do 5 meters now, collect the same money. So by the time you are already at 80%, you have put the same resources that's required to do 100%. So you must have legally and sensibly earned whatever you are being measured to pay. But then contract terms are tight. Different contracts with different terms. But there have been proof people can go to court and all of that, arbitration. They will tell you the man has essentially put the same resources that he would have used to do 100%. And it's not his fault that he didn't go. But there's some contract we got to tell you straight. There are some clients they got to tell you straight. Before you start this work, now waiting, this contract is just a reference, so it's 100,000 contract. It doesn't mean I'll pay you 100,000. At the end of the day, now waiting you do. Now I go pay. So when there's a clear contract like that, it be as you get. All right? They will not pay you a couple extra. They will not. Even half a meter, they will remove it. Until you fight them. You have to fight. So clients are different. And we at Evomec, we are just partners. We give small, they give small. Sometimes you go like this, sometimes you go the other way. Okay. Any other one? Access to the video, I can provide the link. But by next week, you have your own video. You don't understand? You have your own video. That will serve you more interest than another person's video. Does it make sense now? You want to have it, I will send you all the link. Not a problem. But why don't you just wait to have your own? And that one will make one say, you can see when I was recording my own. I said, see me. You have that sense of ownership. And that, you see it, koro. And I know some people will post it on TikTok. And hand some banga. Abi? No, so that they do them. You engage people in the night. You keep yourself 3, 4, 5 people. They begin to give you. What's that they give? You see, specialists. It's not subscribed. They'll be giving you something. Get what's in the column. Gift, Abi. They'll put number on it. And before you know it, they'll be using our video to make money. No, we are hearing it. We are reading it. I'm not a Gen Z now, but we are reading about it. You know, but it's good. It will be good. You are there yourself. You are able to post it. And it's good you post it on a serious site like, sorry, I'm not saying the other ones are not serious. A professional site like LinkedIn, it boosts your profile. You see a lot of people attracted to you, people looking for employer looking for people in that experience. And somehow you just be surprised that somebody just comes to them and goes, I need somebody to do this. They go back to your LinkedIn account. So all those social things is good, but make sure as a professional you also have that one. Is it LinkedIn? Don't even know the spelling. Is it linked or inked? But I did there. So please get yourself registered in those kind of situations too. This kind of short video you post it, you see people, they don't pay. Sorry. I mean, they don't pay. They know they pay. But it pays eventually because you are going to be among professionals and then you are going to be hard. Somebody will post their own and you have fun. Another question? Any other question before we close this session and then we'll talk and then we'll release you for Friday things? Any other question?
This session is more of technical than just safety. My concern is about the maintenance. And I know these kind of projects, the lifespans are always very, very long. Sometimes they outlive the generation that actually installed them. Knowing fully well that they are metals, I know Oga has told us that some of them are so galvanized in such a way that if you can project them above the expected expiry date. But for all I know, that place we are going to install it is not only mashy in nature, it's also salty. Is there any way other than from the manufacturer's coating, as in the coating of the metal, is there any other way we can protect them in form of periodic maintenance in order to enhance elongation?
Can anybody remember how many approach you can use to deal with corrosion? Can you remember what I said about it yesterday or day before yesterday? The coating? Yeah, that's the coating. The second one. I know when I mentioned it, maybe you didn't pay attention to it. Eating it. No? No, I didn't say that. I never talk like that. I don't agree. Now you mentioned I'm an agree. I said no. It's the same thing as galvanization. Galvanization done permanently or galvanization you do small. That's what I know production do. And I said corrosion loss. And I explained that that is easily understood that if you need a 10 mm rod, you go and buy a 12 mm or 16 mm. 10 mm is what you need. And then corrosion, we said, it starts from outside and go inside, not from inside to outside. So if you need a 10 mm, you buy or you estimate for 16 mm or 12 mm. And like I tell you, for a 2 mm rod galvanized to be eaten up like that, it takes a lot of time. So in the design, minus relying on the manufacturer's specification of over 100 years based on their galvanization, we also made provision for corrosion loss. I told you this, our pie we designed in the morning was actually what we have on the site. And then we selected what size of shaft. In the morning, what size of shaft? SS 175, which is dimension is what? What's the size? What does that mean? That dimension. The section is what? 1.75 inches diameter. In this project, 175 is okay, but we selected SS 200. So we have added a 1/4 inch thickness to cater for any possible is attacking the matter on different fronts. So the rod we are going to be seeing on Monday are all SS 200. So we don't need to maintain. You know, we are not in Nigeria. I understand our concern. These are people who are serious people who doesn't take standard and name for fun. Look at the man who have been watching the video. He probably was in 20s in the same company. Right now he's about 70. So there's no way that if they have supplied a bad product 30 years ago, 20 years ago, you understand? They don't joke with their reputation. This organizational reputation is key. Their society does not even favor it. You go court tire. They will take your license. There's no doubt. Every product you shun out, they test it independently, not what you submit. Their own standard organization will just come, and their own is not federal, everything national, NAFDAC, which one? FCCP, SON. No, their own, they even have local government own. And those ones they also have automatic access to your facility. State government will come and tell you this is their code, you must pass. They just come, give me sample, and that's why they make sure you have all those on the product. The date of manufacture is there. Of course, the logo of the manufacturer is there. So if they test on random and they found out, or any client, and they also have open room where clients can provide feedback, not the one that is politicized. You go and pay people to write negative, not Erisco and that woman or something like that. Okay? So you pay somebody to discredit the opponent's product. So all of that, they go check all those feedback, and when immediately they find out anyone is faulty, they will recall. They will not only recall all those products, they will have to compensate whoever has used in the past. Plus total completely 100% refund. So whatever damage happen, you go pay. You go pay tire. So, and that's one of the confidence that, okay, these are people. That's why we went to buy it from the right people, and they gave us a guarantee. So even if we have passed away, so we also did our own over guarantee. So we are not going to maintain it. We only look for another job in LNG. When we finish this one, it's done. So we do it well. Any other work like this come, they call us. That reputation will make us last more than thinking maybe we can. I know you are not thinking along that line. So, but I just, so that we all have confidence that we'll go make it in Ross now, so that they will say we're going to maintain them. Even if we maintain them, it's going to be our costs. And then Nlng will not pay shishi. We told them it's going to last 100. It's not lasting 100. It's our shit now. Also, every contract has warranty and all of that. This is not for subject of discussion. Any other one? And again, before they made that specification for us and produce our product, we provided our soil information. So we provided our environment, that saltiness, the pH value, the salinity, acidity. We did a comprehensive soil test. We have all those figures, and we submitted to them to also manufacture to deal with that. So they didn't just have a blanket guarantee. They relied on the data we provided. So salt is not a problem at this point. All right. Any other one? Online, any other comments? Again, announce, we have all this information, provide your email.
All right. It's in Zubedia and Adoga. At this time, we have taken the question and answer, but just a vote of thanks to everyone who has joined us online and physical. It has been a brain teaser. It has been a good way to go. It has been interactive, and we have come to build a family from a bigger family. I think at this point we say thank you to all of you. Special thanks to Alaji, the facilitator. He is a man that you can always tap from. He is a real seasoned engineer. He thinks one, acts it, and does it. I mean, at this time I say, very big thank you for the knowledge you have impacted, not just to Evomec staff, NLNG, and even the community, the host community we are in. So I will employ you to go back, do more research, and build yourselves. Same way I will read, because you can see I'm always distracted. One mail calling from site. I go out, family go call, girlfriend they call. Today is Friday. So, but thank God for you guys. You are intact, and I know you have gotten enough knowledge, and you have enjoyed a bit of it. So, let's go back, have a good rest, and prepare for Monday, Tuesday for the practicals. And I think you have to come, don't wear bubu or don't wear jalabia, because you will come and change into your PP for that Monday and Tuesday. At least minimum had that. Okay, so you have in the site so that you will be part of it. Souvenirs.
Come and have it. And that's actually what we do. I'm not just saying maybe. We will call back. Some of you here, all of you here who has done this training, when we want to do the work, you will actually see it done. Minus the demo we want to do Monday and Tuesday, so be rest assured, we'll do our best to make sure you have every opportunity to develop yourself, and then you have something to be able to apply for the certification now and get your all of. I mean, it doesn't cost us much. We have the biggest tank goes to the business, our partner Nlng, who has given us that opportunity as a company, Evomec Nigeria Limited, Global Services Nigeria Limited, to be able to demonstrate our capability. So, because if there is no opportunity, this class will not even come. Nlng is rich enough to call beggar or even the company we are buying from. Nlng can easily call them and they will run here. You call them once, they will answer 2 times because they know it's a big dollar. Even though we are not taking as big as they are taking, but the fact that they gave that confidence in us, they relied on us, and then they gave us the opportunity to be able to demonstrate the best tank or the biggest tank of the day go to the business. So again, Nlng will thank you. Again, we have this opportunity if you guys are not even available. Some community, you call them, bring in people. They sell the slot. Abi? Or they say, okay, give us the money for the training. So for the fact that you stick your net out, you demonstrate that you wanted to learn, we should also, the best we can do for you is to make sure we give you every chance to develop yourself. So by tomorrow, maybe when Evomec or any other person can ask become a manufacturer for this technology, you will be beating yourself and we are the first people that did the training in Nigeria now. You know, we are the first set of people that did the installation. So we don't want to also only add the training to your CV for those who are already working or who have not worked. We want you to add it as an installer. So you can say, I'm a pilot now and I'm able to. And then some of you that see Japan, you know, that knowledge is not common. It's not like this knowledge is not common. So it could be a reason for you to say, okay, I'm bringing a special knowledge. I have a special knowledge to travel abroad. You can add all of that to your visa application for, I don't know what they give, because we, in our village, we know they go anywhere. Maybe all this your visa application for employment or whatever it is, say, I sabi this one. And then they will look in America and say, how many people sabi? Okay, this one will be, how the NATO they call them? They are not terrorists. They are not terrorizing alien. Or they use alien in America now. So that could also help your career. That's basically what we are saying. And we are just not going to do it just because we can be paid too. We want to make sure you have it. That technology reside. Because in another place, even with our own private facility, we can sublet contracts. Some of you can float company. You understand? When I started using this thing, it was just like a joke. Carry weather. In Andy, yeah, weather. So I started using it to do static load tests. You know, when we started as a graduate, we like, you know what? We are doing small static load tests, 2,000 kilonewton. We can go and carry container, put sand inside, or cast some concrete, or cast some counterweights to do the test. When the load becomes like 10,000 kilonewton, and you want to carry a truck, almost 20 truck, I want to do a test in Port Harcourt. Let's say I want to test 5,000 kilonewton. And because tests, people don't, it cannot be cost or more expensive than the work itself in terms of contract. Maybe I charge them, for example, maybe I charge them 3 million to do the test. And then I need to move 20 vehicle flatbed to be able to carry the load to do the test. At least one load as of today from Lagos to Port Harcourt will charge you 2 million. And I'm bringing 20 truck. How many is that? For, I'm not doing Joro, not the same, not the price, but even the piling, the entire piling they did, maybe just 40 million. So we use 100 million. Are you going to use 40% of that cost to do tests? So we begin to think out of the box. And now that I have this experience abroad, and I say, you know what? And the code allow it. Shege, let's begin to fabricate it. We don't need to galvanize because you just do the test and come out. You understand? So we started, and people keep buying into it. People keep keying into it. And now most tests that are big, and then you need to move distance, or maybe across water. Even when we reach, maybe I'm going to Soku. Okay, Soku, we can do by road? No. So now after I carry 30, 40 million reach Port Harcourt, I still go higher badge. And bros them they road too. We go still had everything. So by the time we do the cost of the test, 100 million. So with this, I can carry banana boat. Wear my knicker. I just walk out and say, I go for fish. They'll just look me. I do my thing, carry 1 or 2, 3 community. And before they know it, Jack don't reach. So that's where we did some, it failed, we did that, we perfect, we keep on perfecting. Now we'll keep on perfecting it. So with you now having the experience, it helps. That means it's going around. The ministry is getting spreaded, you know. But before you know it, Nlng has had it now, it goes to Shell. Who knows? We can also work another company, they say they have to go, God, we don't do something like this before. You either take it yourself or you come and tell us, Alagi, he don't day. Evomec, he don't day. And all of that. So we are not just doing this. In fact, when we look at the cost we have spent right now, it's already overshooting what actually we are being paid for. It's not because we are being paid for what we ask them to pay. We also quoted for this, not because we want to make profit from it, because we just make sure we impact that knowledge to everybody. And that's why we took it very, very serious. We could do it in one corner and do and then we do like this. Everybody go home. They ask you don't do them, I do them. Who are we doing? Are we doing ourselves? We have to be proud of the country, and we are proud of you, and we hope that after now, we hope benefit for it, for yourself and for your family and for the country. Thank you, everybody. Have a nice weekend.
Please, let me just add this. This month in Nlng, we always have a talk of the month, cover, what's it called? The sharing of the month. For this month of May, it was open communication. And one aspect of open communication is giving the information as it is raw. Being fact-based, getting feedback. And one thing I've observed here is he did not just, he came out even showing you video. This is something some people will restrict some, make you not take better past me syndrome. But in the sense of open communication, you have this. He has told you this is where I got it from. This is where I saw it. So I will still say another applause to Alaji, please. It just occurred to me just now that some other persons might want to keep these boys, the way these guys answer this question, tomorrow they can't drag market with me. But I didn't think of it. And that is the spirit for me. Anything, if you like, I will do what I will do. If you like, you take it. If you like, go and turn it. My conscience is clear. And that is one thing I share and one thing I respect him for. So, Alaji, thank you. Please keep it up. You cannot learn left hand for old age. The good way don't start, continue. Thank you. Bye. On that note, we call it a close. Till we meet on Monday, Tuesday. Thank you. I think we have a picture.
We have to do group photo.
So we all sit as this, just face this side. Can you bring your camera here?
No, we'll be using.
Is it me here from phone? You can use your phone from here now. See whether I can take everybody. Instead of standing up. Let's just face the back. Oh yeah, use your phone now. Later you. You have taken already. Oh yeah, now okay. Admin, they can help you take so that you can also be inside. Now when they are sharing the bank, I go say you know this.
To widen it.
Which one? Ashinko?
Let me.
I mean, it's not upside down.
Let me on those like that.
You look at slogan. Great Evomec. Great Evomec. What kind of phone is that? It's not the phone, no, it's the light. It's the light. It's iPhone now. It's the camera. I mean, it's the lighting. It's the lighting.
Come on, stop that.
From the corner of a toilet. It's the corner of a toilet. You can do all the effects after. You are doing panorama. Great Evomec.
Creating fresh impact. Great Evomec. Creating fresh impact.
Creating fresh impact. Creating fresh impact. Creating fresh impact. You can take from the video and steal it now and crop. Ask this lady, she knows everything. You walk now. Very clear. It's very clear. It's very clear. I'll send it. Is that my phone, Abby? Correct now. Make sure you don't leave your phone behind. Check everything you come with.